circumstances, so it has been quite a challenge. We know that the EU energy system needs profound adaptations to be the infrastructure to make 2050 at the latest, hopefully even earlier, a zero carbon economy possible. And in that respect, we hope that today can give a vision on how the infrastructure, especially on electricity, but also in future on 100% dedicated green hydrogen can be promoted. But before you promote something, I think it's important to have a vision on where it could go. And maybe this is a moment to show the one slide. I wanted to make you aware, also to show you a bit that there has been visionary people who have already, back in 2009, had the vision of a greater grid in the North Seas. So maybe if we can have that slide. We are almost there. Here it is. I hope that you recognize what you see in white is the North Sea. And then, of course, you see UK on the left side, and then the European continent. That drawing comes from Rem Koolhaas, the world-known architect and urbanist. And in 2009, European Climate Foundation, in order to have a credible story on how can Europe decarbonize, basically had envisaged a huge grid in the North Seas. And later today, when Dan Jørgensen will speak about the energy island which Denmark is planning, I think you will understand that this vision from 2009 is now coming true. With that, I think we can move forward, and let me first give the floor to Francisco La Camera, Director General of IRENA.
Thank you, Claude. And it's really a pleasure to see you again and to be here. And we are delighted to organize this timely dialogue with you and the European Investment Bank. At IRENA, we see continued momentum around renewables-based energy transition across our global membership. Last year, despite the pandemic...
Sorry, Francisco, put your camera on.
Oops, it should be, it is on.
We don't see you.
I don't see why. I can try to see if there is...
Yes, that's better.
Okay, so that's good. Just going back. Okay, so I was just greetings everyone here and say that as we at IRENA, we have continued momentum around renewables-based energy transition across our global membership. Last year, despite the pandemic, renewable uptake was at record high. Overall, renewables accounted for 80% of all new capacity, dwarfing the additions from fossil fuel and nuclear. 260 gigawatts of new renewable electricity generation capacity were installed globally, with 34 gigawatts being added in Europe. More is needed as IRENA World Energy Transition Outlook on 1.5 degree energy pathway highlights. I'd like to share 3 key points with you today based on our analysis. First, the technological avenue for a climate-safe energy future. are here clear. Electrification and energy efficiency will be the main driver of the new energy system based on renewable energy and complemented by green hydrogen and modern bioenergy. We are pleased that ARENA's vision, which was until recently considered too progressive or even unrealistic, has become mainstream, and it is shared even by more conservative players. Second, this clarity of vision and priorities is needed to ensure we invest in the future we want and create the right enabling environment. Part of this investment needs to go to infrastructure, including in electricity grids, electric vehicle charging points, and electrolyzer. Third, the new energy reality requires regional approaches, novel strategies, and new partnership. We are seeing a growing recognition of this in Europe, but also in all other regions. The revision of the Trans-European Network of Energy to promote the integration of renewables and to connect regions currently isolated from the European energy market is a good example of it. Fundamentally, it is important to remember that the energy transition is not merely about replacing fossil fuel with other solutions. It's a new system that requires a holistic view, not limited to technologies. This means designing market differently, considering different operational practice and actors, innovating business models, and building the needed infrastructure. And it also means focusing on using the energy transition to reap the socioeconomic benefits for everyone in our societies, while ensuring the transition is inclusive and just. Let me conclude by stressing again today that we have only 10 years left to make a lasting difference. We should not get distracted. We must keep our focus on accelerating the deployment of solutions we have while innovating for the future. The European Union and many of its members are showing great leadership in moving towards a deep decarbonization by mid-century. And ARENA is the right place to disseminate this insight. And we look forward to continue to engage with you on this. Thank you, and back to you, Claude, please.
Great to see that ARENA is really moving the show. You have stated rightly, you were seen a bit too far with 100% renewable scenarios, and now other international organizations are catching up. Now it's my immense pleasure to give the floor to João Galamba, Secretary of State of Energy of Portugal. João, you have been instrumental as presidency of the Council to achieve a general approach of the 27 EU energy ministers last week on the 10-year regulation. So maybe that you could come back a bit on that. And then, of course, Portugal is a real front runner on this fast transition to 100% renewable energy, to green hydrogen, and also spend some time to explain us where you are today as Portugal and how we can learn from you and how we can also integrate the Portuguese renewables and green hydrogen into the European framework. João, it's up to you.
Thank you, Claude. Well, dear Minister of Energy and Spatial Planning, dear Claude, Mr. Director General La Câmara, esteemed audience, thank you for your kind invitation to speak at this conference. ARENA and the EIB are very relevant parties in the design and management of what can be called the Trans-European Network for Energy. And even Luxembourg, with Claude at the helm, though driving through driving a tough negotiation at the European Council, is a trusted ally of Portugal in our common European endeavor to reach union-wide carbon neutrality by 2050. The EU Council had a very successful day last Friday with the adoption of a general approach on the 10E regulation under the Portuguese presidency. This general approach is a commitment towards a green Europe, where infrastructure is the driver for change, a commitment towards an ever closer union. The 10E regulation has a fundamental role to play in enabling the energy transition. The massive investments to be carried out in this decade by all member states in order for us to reach our national and common union goals in 2030 require steady and safe operation of grids and other infrastructure to enable green energy flows and consumption. The union's commitment must also be to allow all member states to diversify their investments in renewable energy production. The 10E, namely, accomplishes this by innovatively allowing landlocked member states to access offshore wind corridors, allowing them access to greater diversity of renewable energy sources. However, we must tackle a new problem: our renewed need for greater flexibility in grid management, the capacity to soak up all generation when available and feed it back into the grid whenever consumption so demands. Technology has advanced in ways that allows us to answer these problems. Battery technology and green hydrogen have immense potential to enable utility-scale energy storage. This is therefore a truly transformative moment where sector integration goes from wish to reality. The power system, the natural gas system, and the transport sector can all be fed by green hydrogen to great effect, and therefore union-wide market integration is not simply achievable by building new electrical grids and gas pipelines. The adopted general approach of the European Council to the 10E regulation is also a breakthrough innovation in this regard. On one hand, the Council agreed to enable cross-sector investments in the transport sector, whereas all projects for the penetration of hydrogen for transport within the 10T, the Trans-European Network for Transport, core network, are eligible to be recognized as projects of common interest. Projects in major ports across Europe will therefore be eligible for financial aid in supplying green hydrogen as an energy vector to consumers in very hard to abate sectors, which accounts for a significant portion of our greenhouse gas emissions, with green hydrogen being our best and sometimes only alternative to electrification. But as I mentioned, connecting Europe simply through building new electrical grid and pipelines is not enough. One must recognize, in particular, when approaching the potential of hydrogen and hydrogen-derived fuels, all means of transportation. And the 10E approach does just that. We collectively recognized investments in ports for the on- and offboarding of hydrogen and hydrogen carriers for shipping, essentially enabling access to broader markets through maritime transportation. Portugal, as a producer, can be connected to Luxembourg or other countries through the port of Rotterdam and Portuguese ports, with the main part of transportation being made from the producing countries. Ports are extraordinarily important hubs for the hydrogen economy, and they are part of the Trans-European Network, networks for energy. You transport energy through grids, through pipelines, but also through ships. Thus, ports are a core part of this new vision of the European energy networks. We collectively recognize within the 10E a concept of proximity that transcends mere geographical proximity, where the north and the south are or can be even closer. If anything, the final version of the 10E should push further in this direction, transcending even the existing corridors whenever opportunities arise that allow for greater market integration. The Union's financial instruments must also be focused in accomplishing this goal. This was not a Portuguese win. This general approach breaks new ground that directly impacts all countries with ports: Spain, Malta, Cyprus, Italy, Greece, and France in the south, and also the Netherlands, Belgium, Denmark, Germany, Finland, Poland, Sweden to the north, the Balkan states, and all the Baltic states, and all the inland countries that are connected to them in a more efficient fashion. We are now able to think of the sea as a new border between member states and to bring forward the instruments necessary to close this distance. If anything, broadening the idea of energy infrastructures to include ports and maritime connections broadens our idea of the internal market and brings closer countries where a simple geographical proximity would not be enough. So we believe that including ports as part of this infrastructure is a European goal that brings European member states closer together. I conclude where I began. The Council made a tremendous achievement in its general approach to the TEN-E regulation. Future negotiations with the European Parliament will now take place within this mindset of enabling the market and new markets to arise. Thank you very much.
Congratulations for your achievements during your presidency and also for all the achievements in Portugal. And lucky to see you soon to help move forward Europe. Now we move over to Artelis, to Christopher Andre, who is the director of Artelis. As a scene setter for more detailed discussions later, we thought it was important to have an academic input to the discussion, what energy infrastructure Europe needs for a 1.5 scenario. So Christopher will lay out the key results of that study, how we have to adapt also regulatory frameworks and planning practices to support the emergence of that green infrastructure to speed up the energy transition. Christopher, it's up to you to give your presentation.
Thank you very much, Claude. Good morning, everyone. So first, let me begin by thanking the organizers of this conference for their very kind invitation and for their proposal that I try to set the scene for this very timely discussion on energy infrastructure and the supporting regulatory framework. My name is Christopher Andre. I'm a director at Artelis. I'm very happy to provide a few thoughts based on recent work related to the future of the European energy system, and particularly on the role of regulation in helping ensure we take advantage of the synergies between the different components of the European economy to reach our decarbonization objectives in a cost-effective and secure way. Next slide, please. First, I would like to spend 1 minute on the size of the challenge. I think this has already been emphasized by a number of the speakers. On the graph from the EEA on the left-hand side of this slide, you can see that the decarbonization of energy supply is making some progress, notably thanks to decarbonization of the power sector and the rollout of renewables. However, the situation in the industry, transport, and residential commercial sectors is where most of the challenge lies. We really need all hands on deck if we are to succeed. However, and as I indicate on the right-hand side of this slide, solutions do exist. And we do have already seen positive signs, for example, in terms of decoupling between economic activity and CO2 emissions or the scale of investment in renewables, as has already been emphasized by Irina. Next slide, please. This figure shows the required installed capacities in a number of scenarios built by the European Commission when assessing the impacts of a more ambitious greenhouse gas reduction target by 2030. So you see these different timelines. So I would like to focus on the 4 bars on the right-hand side of this figure, which show the investment in generation technology on the electricity side, in terms of offshore wind, onshore wind, and solar PV. You see a huge scale up of investment between 2030 and 2050. Next slide, please. This second figure tells a similar story, but with an emphasis on the global investment challenge. We see here the annual capital investment required in the net zero pathway published by IEA a couple of weeks back. And again, accelerating is not an option. We see that there is a huge challenge in terms of investment. However, I would argue that this is not the only challenge that we're facing. So, next slide. As mentioned earlier, scaling up renewables and energy efficiency measures are no regret options. However, there are still important uncertainties on the route to follow to decarbonize a number of end users, including hard to abate sectors, such as in aviation, long-distance trucking, and some process in the industry. I think that at this stage, it is fair to say that there are several plausible visions that are competing, in particular on the extent of the role of hydrogen. Other uncertainties are related to the speed at which some technical innovations will find their way to the market and to the steepness of decline of cost of technologies. So the key question I would like to explore is how should the analysis of potential infrastructure investments be structured in order to reveal the most promising options? Next slide, please. So there are three dimensions that I think the regulatory framework should include at its core when assessing and selecting infrastructure projects. The first dimension is time, the second is related to space, and the third one corresponds to system thinking, or in other words, taking the flexibility that can be harnessed between the different sectors and vectors of the European economy into account when planning energy systems. So I'll go through each of them one by one. So next slide. Yeah, thank you. So let's begin with the time dimension. So there is no doubt that many of the infrastructure investments made today will still be around in the 2050s. It is therefore very important to make sure that the projects we are going to select next are compatible with a net zero future in order to avoid stranded assets or lock-in situations. The regulatory framework should therefore include an assessment of projects considering their entire lifetime, so that we do not end up selecting projects that are only beneficial on the short term. Next slide, please. The second dimension that should be embedded at the core of the regulation is related to regional cooperation. This has already also been emphasized by previous speakers. So adopting an EU-wide approach to the selection of projects would allow to recognize the potential interactions between candidate infrastructure projects. Here too, looking at the big picture can help identify the most relevant set of projects and to avoid overinvestments by recognizing that flexibility resources are pooled across regions via electricity, gas, and in the future, hydrogen networks. Next slide, please. And finally, I reached the third dimension, I think the most important one that I've called system thinking. It is based on the recognition that the level of interlinkages between the various parts of the energy system will only increase in the future due to the expected deployment of electrolyzers, hybrid heat pumps, electric vehicles, potentially hydrogen turbines. So these are all technologies that link different vectors. So adopting a holistic or multi-energy approach when assessing infrastructure needs and selecting projects is essential to properly consider the flexibility of all sectors. This can have an important impact on the actual need to invest in pipelines and wires. Indeed, if one disregards the flexibility that can be provided by other sectors, there will likely be overinvestments that will end up as stranded assets. I've listed a number of phenomena on this slide that can impact the potential need for infrastructure projects, but let me just take one of these examples. Next slide, please. So on this figure, I show the operations of a heat pump across each hour for 1 year. As temperature decreases, the heat pump usually switches to a backup heater. You can see here that there are significant electricity demand peaks. In the case this backup is electric. So these are the purple areas. So these peaks would have to be covered by highly flexible electricity generation assets that would only be used for a very small number of hours per year. However, in some configurations, it may be possible to use a hybrid heat pump with a gas or hydrogen boiler as backup, particularly where gas infrastructure exists. Therefore, hybrid consumption technologies can reduce the need for power generation assets and networks, which would be required to cover demand peaks. In this example, I've focused on the flexibility that the heat and gas sectors can provide to the electricity sector, but they are exactly the same phenomena that can go in the other way around, where the flexibility of the electricity sector can help reduce the need for gas infrastructure. So my key message is that in order to take into account these sources of flexibility, it is necessary to adopt a system-wide approach to the planning of the electricity, gas, and infrastructure, and hydrogen infrastructure, sorry. So you can go to the next slide, and the next one, please. Next one, please. Yeah, thank you. So you may ask, isn't what you're describing an overly complicated task if one must consider entire pathways, regional cooperation, and adopting a multi-energy or holistic point of view? I think it is not. There have been much progress in terms of simulation tools, the development of methodologies that allow to take these phenomena into account, and the establishment of robust and open source datasets. That makes such an approach not only possible, but very valuable. So let me briefly present a study where we've tried to apply these principles. It is a study Artelis has carried out on behalf of the European Climate Foundation. The objective is to evaluate the need for new electricity, hydrogen, and methane infrastructure. To do so, we have optimized the investments in the infrastructure using a multi-energy modeling framework. Next slide, please. So very shortly, in terms of the methodology, what we have done, we have taken as assumption the level of demand for electricity, hydrogen, and methane, taken some assumptions on the installed capacities in generation technologies, the potential for biomethane, and then have asked the model to optimize the deployment of infrastructure, both in the electricity, hydrogen, and methane sectors, and using a holistic modeling approach that recognizes the synergies and interdependencies between all the components of the energy system. So let's check the key results of adopting such an approach. By the way, if you're interested in the detailed results, the report is available on Artelis website. So next slide, please. I'll just focus now on three main insights that are relevant, I think, for 10E. So let's begin on the left-hand side. The first key insight is that in all the scenarios that we have considered, we have found that significant investment in cross-border electricity infrastructure is required. This reveals that in all cases, one can expect a significant scale-up of the electricity grid. This shows the importance of streamlining permitting processes, for example, and potentially to adapt some of the cost-benefit analysis procedures in particular for hybrid assets. The second insight is that is related to hydrogen. And in that sector, we have found that cross-border hydrogen infrastructure will be relevant. However, the level of the required hydrogen infrastructure is rather uncertain. It varies quite substantially from one scenario to the next. For example, when varying the geographic allocation of renewable across Europe, this can have major impact in terms of the need for hydrogen infrastructure. And this underlines my previous point about the need to jointly plan electricity and hydrogen infrastructure, since they are highly interdependent. Finally, the third insight is that we have found that there is no need for any additional methane infrastructure to meet EU security of supply. Another interesting finding is that goes into the direction of system thinking, is that there is a competition between hydrogen and e-methane and biomethane for the use of existing gas pipelines. And this again reinforces my message. We have to plan these infrastructure in a joint way. And next slide, please. With this, I reach the end of my presentation. I hope I've managed to convince you that a holistic approach is key to tackling this huge challenge we have in front of us. We only have limited time to scale up investments, and adopting a holistic approach to infrastructure planning is required to do it efficiently by properly accounting for the flexibility that can be offered by the various components of the European economy. I think that not only the infrastructure projects, but also the regulatory framework itself should be future-proof and act as a catalyst for the transition by including safeguards against ineffective investments, and most importantly, by structurally embedding mechanisms incentivizing the emergence of synergies in order to help us all reach a net zero system by 2050 in a cost-effective and secure manner. This will be my conclusion. I would like to thank you for your attention, and thank you to the organizers again for the invitation. I'm looking forward to listening to the different panels and for this very timely discussion on the update of the regulatory framework. Thank you.
For leaving us, maybe one follow-up question. How do we link support schemes for renewables with infrastructure? And we will have a discussion on state aid regime soon, and some are arguing that we should go for completely technology neutral tendering systems. Is there a relation between support schemes and the ability of infrastructure planning? And what would be your advice on that? The second is, I think that we have already now quite a well-integrated pentalateral market, Germany, France, Benelux, Scandinavian market. Later we will hear from Simeon Hackspiel how the pentalateral market is modeling this high renewable future. Have you, the one region where I think there is more work to be done is Southeast Europe, with some countries being in EU and some countries being outside the EU. Have you seen, or do you see some opportunities to work also on more detailed opportunities, more detailed modeling for that part of Europe, for Southeast Europe?
Yeah, so perhaps taking the first question on the link between support schemes and infrastructure, I think one of the key lessons that we have seen in this work is that where the investments in renewable take place can have a huge impact on the required level of infrastructure. In particular, if there is a good level of co-location between demand for hydrogen and the deployment of renewables. So I think there is a strong link here. Then how to implement this link in the regulatory framework, that would require perhaps a more extensive discussion. But I think indeed it is important to have that link in mind. And with regards to Southeastern Europe, indeed, I think there too, there is a huge challenge in order to understand how to bring the whole region in towards the transition toward a net zero energy system. We're currently undertaking some studies where we include all countries, indifferently if they are within the EU or outside the EU, in order to showcase what could be the pathways that they could follow in order to meet net zero.
Thank you very much for this academic input. I think it shows that we have the tools to really have a good view of what infrastructure is needed. Then we can move to the first panel, the challenge of integrating high renewable volumes into the grid. Before presenting the different speakers, maybe one housekeeping item. To make it interactive, all those who listen to us, we are more than 200 now, you should actively go to the chat and then also put questions which you want to take up, and Guy and Jeremy, who are following the conference, they will then take the questions up so that we can also have your input as the auditors from this conference. Then it's my pleasure to welcome Giles Dixon, who is the CEO of Wind Europe, Dolph Gielen, who is running the IRENA Innovation and Technology Center in Bonn, Werner Götz, who is the CEO of Transnet BV, and Simeon Hackspiel, the Energy Commissioner for Luxembourg, but also one of the coordinators of the working group of the Pentalateral Forum, who is basically planning the foresight on security of supply. We had expected also to have an input from Dan Jorgensen, but there seems to be a problem in his agenda, so we will listen to him later in the last panel. With that, maybe I can then move over to Giles Dixon to give a bit of a view on what will happen on wind, onshore, offshore, and what are the infrastructure needs you need as a thriving industry to be able to run fast, so is the infrastructure deployed fast enough to catch up? Giles, up to you.
Thank you very much, Claude, and thank you for the invitation to speak this morning. I hope my slides are visible. Thank you. I'm going to begin by showing how wind energy is going to evolve over the next 30 years. Next slide, please. This is wind energy capacity in Europe today in gigawatts. The dark blue is onshore, the light blue is offshore. By 2030, it will look like this. Next. And by 2050, the European Union wants us to have this much. Thank you. A huge increase in offshore, an even bigger increase in onshore wind. This capacity expansion is deliverable, provided we simplify the permitting rules and procedures and put enough staff in the permitting authorities, provided we engage the general public so that they continue to support the expansion, especially of onshore wind, and provided we build out the grid. What do these numbers mean for Europe's electricity mix? Next slide, please. This is the Commission's most recent COVID mix scenario for the evolution of the EU's electricity mix to 2050. You can see onshore wind in the dark blue becomes the #1 source of the electricity we consume, and wind in total is 50% of all the power we consume. You notice also there's a major increase in total electricity consumption. What do these numbers mean for the total energy mix? Next slide, please. It means that where electricity is only 1/4 of today's total energy mix, that will rise to 57% by 2050. And electricity will also be the source of the additional 18%, that's the two lighter blues and the yellow, that is renewable hydrogen and its derivatives. The development of hydrogen and its derivatives will entail some repurposing of today's gas grid, but this increase in electricity in the energy mix will require a huge increase in investments in our electricity grids. Is this new energy system affordable? Well, we've crunched the numbers and concluded that yes, it is. First of all, that 57% direct electrification is all the things in buildings, transport, and industry that we can electrify directly. And where we can electrify something directly, it will always be cheaper and more energy efficient to do so. It will always make economic sense. The other 18%, where the hydrogen and its derivatives come in, is for the hard to abate sectors which we cannot electrify directly. The total energy system costs for what you see in 2050 compared to today are exactly the same 10% of EU GDP. So we're paying no more for our energy under this renewables-based, electrified, decarbonized energy system in 2050 than we are today. The costs of the renewables will continue to fall, and that's the main reason why we won't be paying any more in total energy system costs by 2050. Where we will be paying more, of course, is for the electricity grids themselves. Next slide, please. To deliver what we've just seen, this is the increase in total electricity grid investments that we need. You'll see most of it is blue. It's the low and medium voltage systems. That's because of the increase in EV charging stations, solar PV, small onshore wind, increased electric loads in buildings with the electrification of heating. We will need, as part of this, to ensure bi-directional flows of power between the transmission and distribution networks. Crucially, we will also need to optimize all of our existing grid assets. That's partly about minimizing losses, but it's crucially that today we are not optimizing our existing electricity grid capacity. The grids are not carrying as much electricity as they could. They are not fully efficient. Now, the grids are going to need to carry much more electricity, so we must invest in grid optimization technologies. If we don't, if we carry on with today's inefficiencies, the operating costs of our transmission grids will be double what they are today, and of our distribution grids, they will be triple what they are today. So we must make today's grid and all the future grids more efficient. The technologies are there to optimize the grids, advanced monitoring, conversion, and system operation control. But the regulation of grids and system operators needs to evolve as well so that it rewards the optimization of existing assets and the savings that they bring. Crucially, we need the TSOs to move away from a purely CapEx to a total expenditure, a TOTEX-based investment framework. Now, of course, as you can see here, we need a lot of investments too in the big transmission networks, interconnectors between member states of the EU. 50 gigawatts is all we have today. ENSO-E say we need to add 85 gigawatts to that by 2030. They are right. Look at the growth in offshore wind. We have quite a lot today already. We're going to have 20 times as much by 2050. That needs huge investments in offshore grid infrastructure. I'm afraid, Claude, ministers, ladies and gentlemen, today's grid investment plans, today's TYNDP do not deliver the total of these investment requirements that I have just described in the grid. Next year's TYNDP will be absolutely crucial. So will be the PCI list of 2023. Of course, TYNDP needs to be updated to reflect the new 55% goal for 2030. Structural changes are also needed, including to permitting. It's just not right that over 1/3 of the current TYNDP project pipeline has already been in development for over 10 years. Now, some people say it's very hard to build new transmission lines onshore in Europe, and they point to Germany, and we'll be hearing more about this later. Well, let's look at the numbers. Germany wants to build nearly 8,000 kilometers of new T lines over the next 10 years. They've already built 1,600 kilometers. They've got another 700 kilometers under construction, 3,000 more in the approval process. The German North-South grid development plan is happening. It is going forward. France and Belgium are developing green corridors with EU money underneath their overhead lines in wooded areas. And this is increasing biodiversity and public acceptance. So the transmission investments can work. My final point, it's so important. The planning of the grid is going to need so much more coordination and collaboration than we've had before, between governments, but also between governments, TSOs, regulators, generators, and other stakeholders. And nowhere will that be more important than in the offshore grid. Next, final slide, please. What you see here is, we seem to have lost it. I was going to show you a map of the Kriegers Flak offshore wind farm in the Baltic Sea, the first in Europe that has more than one grid connection. It has a grid connection to Germany and to Denmark. That involved extensive coordination and planning. We will have many more of these so-called hybrid offshore wind farms with multiple grid connections, hub and spoke arrangements with artificial islands, natural islands in the North Sea and Baltic as well. This will need huge coordination between all the actors, and crucially, as we finalize the 10E regulation, now it's very important that something should be in the regulation on the integrated network development planning of offshore grids. Thank you very much.
Ton micro, Claude.
Thank you. Making us aware that we have not only to move on the deployment of renewables, but also on the deployment of infrastructure. Do you hear me? Because I have a bit of a doubt.
Yes, it's okay.
It's okay. Good. Then let's pass over to Dolf Gielen. Dolf, who is running the Innovation and Technology Center of IRENA in Bonn. So first, Dolf, thank you for helping us in organizing this conference, of being a co-host. And what is IRENA's intelligence on where are we today on how do we build a system which is integrating fast renewables, but on the other hand, also trying to do this at the lowest cost and without stranded investments. Dolf, up to you.
Yeah, thank you very much, Claude. I can build on what the previous speakers have said. Globally, in our World Energy Transitions Outlook, we look at a 1.5 degree pathway. We think globally we need 8,000 gigawatts of wind power by 2050. And by that time, wind would account for around 30% of global generation. And Giles just presented that Europe, EU is about 1,300 gigawatts of that. So it's a significant chunk, but my point is that this is a global issue. It's not just a European issue. We need grids to evacuate that power, and the progress on the TANI is in that sense very encouraging. Also the component on the offshore grid planning that is in there, and the opportunity then for these rich Luxembourg investors to pay for all of this. So that is good. But apart from grids, indeed, flexibility is needed to deal with these high shares of variable renewables going forward. And there are opportunities for smart investments to reduce the cost for that grid integration. So I want to make a few points there. We are preparing a report for the G20 on the integration of offshore wind, and that should be released at their energy ministerial meeting next week. And it's based on the recommendations from our collaborative framework on offshore wind. Earlier this week, I was in a meeting with the leaders of offshore wind in Europe, and they indeed also raised the issue of permitting and planning certainty as one of the main challenges in Europe, as well as the need for reasonable returns on projects, and that they face a challenge that there's a strong requirement also for local content in some jurisdictions. So it's a complex planning problem, and as Giles has said, the planning for grid lines takes many years in Europe. So the reduction of let's say provision of certainty, to put it positively, is very important in going forward and in realizing these investments. If you move to the next slide. So it's a bit of schematic representation. We need today's flexibility in power systems comes from the supply side, so dispatchable, especially fossil plants. In the future, we need much more flexibility coming from grids and from the demand side, the distributed energy resources. I was looking at the wind generation numbers for Europe, for Germany. Last year and this year for the first 4 months, and this year the wind generation in Germany was 25% lower than what it was last year. So you need also not only power systems that are able to deal with issues on a daily, hourly scale or minute scale, but also that deal with these type of seasonal fluctuations, and more geographical integration, more spread, and as well as hydrogen, which was already mentioned, green hydrogen, can play a role in that context. Moving to the next slide. So we see 3 main trends. Electrification was already mentioned by a number of speakers. Much more of these decentralized sources. Wind, a large part of wind is part of that. Especially onshore, but also digitalization is really critical. So we need these smart grids to allow that grid of the future to operate, but also to reduce the cost for that energy system of the future. And then moving to the next slide. So how do we realize? How do we create that flexibility? We need 4 things. We need, of course, enabling technologies, including the grids, including storage, but we also need the right market design and regulations. Notably, we need electricity prices that reflect scarcity in time and geographically. We need more flexibility in the system operation. So what was mentioned, better use of the existing grid capacities is an important component there. We also need new business models to be more widely deployed, such as aggregators, such as peer-to-peer trading, to reap the full benefits. And then a final slide. We need to work on the digitalization, smart grids, if you like, solutions for the existing infrastructure that has 4 dimensions. We need certain equipment, we need the right IT solutions, we need better communication systems, and we need advanced analytics. And what this graph shows is some of the types of investments that are needed to indeed create that flexibility. Distribution nets alone will need in the coming 10 years investments in Europe of around 40 billion euros per year to make this happen. So that is really the investments in distribution nets is significantly higher than the investment needs in the transmission nets, which of course are also needed. And I'll close my introductory remarks there. Thank you very much.
Thank you, Dolf. Also stressing that there is possibilities to optimize the existing grid and that we should not underestimate that aspect. Next speaker is Simeon Hackspiel. So he's looking for security supply in Luxembourg, but beyond that, he is also leading the working group 2 of Pentalateral Forum, and that working group is the working group where basically the sophisticated studies are done on where is the grid going in the Pentalateral region, and what kind of cooperation is there needed between the grid operators, but also between the member states of that region. So Simeon, if you could show us a bit what Panda is doing to advance this kind of 100% renewable-based energy system.
Thank you, Claude, and welcome to all of you. Many thanks for having me. My name is Simeon Hackspiel. I'm the Energy Commissioner of Luxembourg, and as introduced already, also have the pleasure to be one of the co-chairs of the Panda support groups, and then we'll try to give you some insights. I think it links quite nicely with presentations of the previous speakers. If you could go to the next slide, please. Right, next one, please. So just a very short reminder of who we are actually. So we are talking about the Pentalateral Energy Forum, so collaboration of 7 countries in Central Western Europe in the field of energy, involving a multitude of stakeholders. So we are talking about ministries, but also very importantly, TSOs, regulators, the European Commission and market parties. And jointly, we have been able to move fast on certain topics and also be a front runner specifically in the field of market integration. You will see on the next slide a couple of exemplary milestones of our track record. If you go to the next slide, please. So these are just a couple of milestones that we've reached during 15 years of Panda cooperation. So you see that there's actually a wide range of topics that we deal with, but all related to energy market and infrastructure. And this is actually a very important basis that we build upon when we come to the specific topic of my talk today, which is the grid challenge in the Pentalateral energy region. And this is depicted on the next slide, please. All right, so looking at the various challenges and changes that will need to come in the next years and decades even, we have looked at different development plans from different European institutions, and even if they're not necessarily delivering on all the aspects we are wishing for, as pointed out by Giles previously, what we see here very clearly is that there are major challenges, and there are major challenges also specifically for the Pentalateral energy region. So we see on the left-hand side the electricity system, with really many projects that are either planned or already in the pipeline. And as was rightly said, so this is not necessarily where it ends. Huh? So we have to deal with a bit of a moving target as well. So projects are adapting, also regulatory frameworks are adapting, and we expect that even more could come in the next years and decades, making the challenge even bigger. So what we have identified looking at these different development plans for electrons on the one hand side, but molecules obviously also on the other hand side is 4 major challenges. Some of them were already explained by previous speakers, so I will brief on them. So for renewables integration, we believe that offshore wind integration and the massive scale we are talking about is really one of the key challenges for the whole of Europe, certainly, but for the Pentalateral region specifically. So the question is basically, having a broad set of countries, also landlocked countries in the region, the main question is basically how can we bring offshore wind energy to the places where the electricity is actually consumed? And there, obviously, we are talking about a grid challenge in the field of electricity. Second challenge, hydrogen. So we're talking about a whole new type of infrastructure. And there's certain visions already being developed, and we are happy to be part of those visions. You see an example on the right-hand side, and you also see an example of why this is really a challenge, which is essentially a bit similar to the one we have in electricity. So the consumption, and this is the small figure that you see, is really very spread out over the whole of Europe. And of course, we need to make sure that energy can be consumed where it is actually needed. And talking about hydrogen, we've heard it before. We're also talking about shipping. So bring in hydrogen from ports to spots inland where it shall be consumed. Third challenge, how do we use existing assets in the best way? And there we're talking notably about natural gas infrastructure and possibilities, opportunities really to repurpose and make best use of it in order to avoid stranded assets. Fourth challenge, and this will be a bit of my focus in the next couple of slides, is the interplay between the sectors. So we cannot anymore take a look in silos on electricity grids, on hydrogen grids, gas grids, but we really need a comprehensive approach and a comprehensive viewpoint to make sure we will get a future-proof and renewable-based energy system. So these are various challenges. If you go to the next slide, please. We have a couple of elements that we can build upon in the Penta region, and I will mention them very briefly. So already today, the energy system across Penta countries is actually quite highly integrated. So what we do have strong physical electricity and gas networks with a very high level of security of supply. We have high levels of interconnection across the region. We have a comparatively high penetration of renewables, specifically in the electricity sector. So certain experience already, even if, of course, we will tackle the new ones as depicted already. We have a reliable institutional framework, specifically with respect to markets. So building, for instance, on the expertise and also the functional flow-based market coupling throughout the region, which was also a major milestone, also very closely related to the Penta region. And we have a shared commitment to maintain high levels of reliability of energy supply with a dedicated support group working on this topic. Last but not least, we have a political commitment and guidance received from ministers during a recent meeting beginning of this year, that a common understanding on how an integrated system could look like in the region is key for a sustainable, decarbonized, reliable, and affordable supply of energy in each of our countries. So what are we after is depicted on the next slide, please. So essentially, against the background of the challenges described and the mandate received from our ministers, our perspective and objective is basically to reunite different dimensions of energy systems integration. And we're talking here about regional integration on the one hand side. So this is an integrative aspect of energy system integration, but then of course also the sectorial integration as already depicted. And what we are after is basically the crossing of those two dimensions, and the motivation for that comes from the fact that a comprehensive perspective, if properly implemented, and that's an important prerequisite, allows to achieve significantly better outcomes than the uncoordinated combination of small individual elements. We are convinced that system integration is the right pathway to decarbonize the economy, and specifically sectors other than energy. So the hard-to-abate sectors specifically, which were already mentioned. And we believe that an integrated approach between the different sectors, hydrogen, electricity, planning is essential, and coordination with natural gas aimed at repurposing is required. In other words, and this is actually valid for both dimensions depicted here, and even more so for the crossing of them, integrated energy infrastructure is a key enabler of system integration. What we are talking about here is internal and cross-border networks. We are talking about the optimization and use of existing infrastructure. We are talking about efficient deployment of large electrolyzer facilities, which are also part of the necessary infrastructure. Coordination between hydrogen and electricity network planning, and also the adaptation, coordination with new types of demand. And here we're talking specifically about the big challenge coming from the transport sector. So while we are doing all this, we need to keep focus on the overall objectives of decarbonization and social welfare, while allowing sector integration to unfold. So sector integration per se is not an objective, but it is a very important means to get to the actual objectives of decarbonization. Last but not least, what I want to mention here in this slide is that you could even add a third dimension, which is hard to depict on a slide, so I'm mentioning it orally. So an additional dimension, which is extremely crucial actually for the work we are doing, is the institutional one. So involving the actors and integrating really the different actors involved in the different topics. And here we're talking about policymakers, we're talking about project developers, investors, system operators, regulators, and of course also the public. Penta, through its governance and setup, really involves a large range of those relevant sectors, and thus we believe we can really add value. Coming to my last slide, please. This is basically just concluding and wrapping up. So within the context described, it is really Penta's ambition to advance the field of integrated energy systems along several dimensions. So we intend to develop a common Penta long-term vision on a decarbonized and integrated energy system, including the benefits of regional and sectorial integration. We intend to further develop a better understanding of this topic by focusing on a specifically relevant field of integrated energy infrastructure in the region. As such, act as a frontrunner in the European ambition of an integrated and climate-neutral energy system. A bit more concretely, provide questions and recommendations to the upcoming EU legislative proposals, such as the Fit for 55 package and its implementation, the hydrogen and decarbonized gas market package, and also the regulatory framework for demand-side flexibility. Last but not least, we also intend to take a regional look at network development plans such as the ones depicted previously. With that, I would like to close, and I would like to thank you once again for having me, and looking forward to the remainder of the conference.
Simeon, and then we can move over to Werner Götz. So Transnet BW is running the electricity or the energy infrastructure also in another landlocked country, which is Baden-Württemberg. I understand that, so everybody knows that Baden-Württemberg is messy, there's other big industries, but I don't know if everybody has understood that Baden-Württemberg is undergoing really an extremely fast phasing out of nuclear reactors, of coal reactors. It is in itself a country where there are not so many wind turbines. You are trying to do through your governmental policies a lot of solar. So I think it's for us an interesting country. Also, as Luxembourg, we are probably in a bit similar situation. Big industry, not so many opportunities to produce at home, especially wind. So how are you coping with these different challenges? Mr. Goetz.
Yes, Claude, thank you very much for that introduction and for pointing out the situation we are in. And I will try to give you a short and brief overview about the situation of a TSO in Baden-Württemberg. And I will start with the first slide, please. And this slide basically should picture from or through the eyes of a TSO where we are. And you already pointed out that we are in a big transition process. And for Baden-Württemberg specifically, we've been depending on fossil fuels and coal, and phasing out of these two sources, energy sources, actually requires a big transition. To picture that on a German scale, a couple of years ago, Germany depended on 450 large-scale power stations, most of them centralized at the centers of the demand. And even today, we have more than 2 million, probably in the range of almost 3 million decentralized renewable generation sources, mainly based on photovoltaics and wind. And for us as a TSO, that basically means that we have a dimension which is quite challenging. And the first part of that 3-column slide shows basically our view on 2050. And we already heard from the previous speakers that we are not only looking at, let's say, a decent increase, we are looking at tripling or even factors 4 or 5 with regard to the capacity which is required on the wind and photovoltaic side. So what does that mean for us as a TSO? Actually, we have to cope with 3 effects. The first is quite obviously generating units today are depending on weather conditions. So we have a volatile and variable generation, which we have to align and synchronize with the demand. The second challenge obviously is, well, pretty obvious as well. Generating units are placed at locations where generation is possible, and that's regarding to Germany for wind, mainly in the north, and for photovoltaics, mainly in the south. So that brings in a regional geographical challenge and the transportation challenge. And the third dimension, I think that's was already addressed as well. We have to think the energy transition on a European scale. And that means that we have to provide an infrastructure which is very much integrated in Europe. And therefore, we need transition capacities as well. So what's the reactions we need to have? And I've tried to point that down in 3 main categories. Number 1 is we need a holistic planning. And that requires a European scale planning concept, as well as we heard from other speakers, as well as sectorial integration. The second one, optimization of the existing grid. And the reason for that is because that's on an economic scale, the most efficient and the most valuable step forward. We are right now considering more than 20% increase of the transport capacity by 2030. And column number 3 is grid construction and expansion. And I think that's a necessity as well. If you can give me the next slide, please. So I will focus today on the second issue, optimization of the existing grid. And even there, we have a wide variety of different tools in our toolbox. Some of them are linked to hardware, some of them are linked to software. And I do not want to go into much details. This slide only should indicate that there is a variety of different options. Most are linked to providing the flexibility required for coping with the energy transition. And I will focus today on flexibility assets. And the reason for that is that we are about to build and develop what I think is a very marvelous new tool. We call it Netzbooster, and I will take a few minutes to outline how that works and what's the gain and benefit for us with that technology. So the next slide actually intends to provide you a short description how this new grid component works technically. A Netzbooster, technically speaking, is a battery systems. In our case, it's a 250 megawatt and 250 megawatt hour capacity battery, which has a highly sophisticated, innovative control component, which allows us to integrate that grid component into our existing grid. So how does it work? And I'm trying to describe that with these 4 little pictures. If we start on the left side, the outlined concept is that we expect congestion somewhere in the middle of Germany. So the location geographically of that battery system is in the south of Germany, and it's located near our expected load centers. So what we normally do is we operate our grid within an N-1 concept, which basically means that we allow one grid component to fail, and we do not allow any interactions, any problems which would cause any security of supply issues with you as a customer. So in that example on the left side, you see basically that the south grid connection point is connected by 2 lines. And in order to provide an N-1 operation scheme, we would not use the full capacity of each of the 2 lines, because if one line fails, the other line should cope. And that basically means that we operate these 2 lines, if you would say so, not efficient, only with a range of 50%. So now our grid component Netzbooster comes into play. We locate that in the south, and what we do now is we operate the 2 lines by 100%. And that's the second little chart. If we now have a failure in one of these lines, we actually have 2 problems to solve. The first problem is in the north, because we have more generating capacity than we can transport to the south, and that's solved relatively easily by the IT software integrated in our control system. So what we basically do is we reduce the generation capacity of offshore wind farms. The second problem is a little bit more challenging, because now we have the situation that the energy required in the south cannot be transported. So now the battery system helps, and the 250 megawatt hours actually buy us an hour, because we now switch on the battery system, which then covers the supply situation in the south for 1 hour. And the 1 hour is enough to call upon, let's say, traditional fossil units, so probably a gas turbine, which then after that hour will take over and gives us sufficient time to replace or repair the failed line. So at the end of the day, the battery system sits there waiting for a failure all year round. But the economic advantage for us is that for the entire year, we can utilize the existing line system on a much higher scale than we would be able to do that without that battery system. So economically, that pays off in a very short period of time, and is a technical component which allows us to utilize the grid on a higher level, and also provides us flexibility and other grid services. So next slide, please. So that's basically my last slide, which I tried to summarize a little bit. What's the perspective for that Netzbooster system for us is. We would like to collect experience with that pilot project, and our vision is that we will have a network of battery systems in the north and in the south, in order to provide us with flexibility, in order to provide us with a mean to more and higher utilize our existing grid. We were hoping that a single component like a battery system is a component which can be built and put into operation in a very short period of time. That's something which surprisingly didn't work out as good as we hoped. Even with a project like that, we had to overcome local public resistances. And well, I think probably the downside is listening to all the speakers, we are in full agreement that the energy transition is required. We are in full agreement with the public opinion that energy transition is necessary, and everybody supports that, up to the time when energy transition comes to the own front yard. And then we are stuck in problems and troubles, and speeding up permitting process is definitely one of the requirements to make energy transition successful. So what's my conclusion? A successful energy transition definitely will require the adoption of the grid infrastructure. We there have 3 necessary steps. I repeat that, I already mentioned that step 1 is, or position 1 is, we need a holistic planning, and that integrating the regional and sectoral integration. We need to optimize our existing grid in order to make the energy transition from an economic standpoint feasible. But nevertheless, we also need to expand and construct new lines. And for that, we need to speed up the licensing permitting process, and we need to find a way to generate acceptance for these projects. And I really would hope with that regard that we have an alignment, a political alignment, and an alignment with the leading scientists as well. Thank you very much. That was the brief overview with regard to the position of a TSO in that transition road.
Dear Werner, thank you for boosting our audience with your NETS booster. I think that's really a thrilling new idea. And in Luxembourg, we have also at least started to think roughly how batteries could also help our system and the system security. Maybe one first question to you. The EU legislation is, personally, I find extremely, and if not too restrictive, on allowing TSOs to operate batteries. So basically you design it and then you try to find somebody who runs it. So how do you implement it concrete? Or is the notion of pilot project protecting in a certain sense first of these battery boosters?
Well, the EU regulation allows the operation of battery systems only if a battery system is a so-called fully integrated network component. So we strongly believe that this component as a system which only is curing or intended to cure failures clearly is an integrated network component. However, the present situation with regard to the legal framework in Germany has not a clear view. So option 1 then would be we have clarity from the legal framework that we can operate this battery system. Then we will do that. That's definitely the preferred option. The fallback plan is, since we decide not to wait until we have a political decision on that, because that probably takes another 1 or 2 years. So the fallback option would be, if the legal framework would not allow us to operate that, we would sell it to the market.
Thank you for that answer, because that's also the question we try to solve in Luxembourg, and we will probably catch up on that. One further question to Giles Dixon. Electrolyzers will, with batteries, be flexibility boosters to stay with the wording. So what is the wind industry analyzes, and is there, what are the innovations we can expect from wind industry on electrolyzers, and how do you see electrolyzers in that basically optimizing of the power system.
Thank you, Claude. The wind industry is already working very actively on the development of wind plus hydrogen production, both from onshore wind and offshore wind. Wind energy lends itself very well to electrolysis because it has increasingly high capacity factors that allow you to run your electrolyzers at 50% load. And as we know, there's significant advantage in being able to electrolyze at 50% load plus. There's still an open question as to where is the optimum place to locate electrolyzers. Close to the renewable energy production or close to where the hydrogen is going to be consumed? We'll have a bit of both. But increasingly, the wind energy industry is looking at, well, can we put electrolyzers inside wind turbines? Inside wind farms, there is one pilot project in Denmark already, which has an electrolysis facility inside an onshore wind farm.
Thank you for that. And maybe one word on the ongoing 10E negotiations. At the end of the negotiations, we were stuck on a sentence which I had proposed on localizing, making sure that the electrolyzers in the European financing of 10E should be linked to renewables. And that is one ongoing item where I hope that the Parliament can help us to move further in the negotiations. One question to Simeon. Thank you for that very holistic view. When will Pentalateral be able to have so this study which is ongoing? When do you foresee to have it finalized? And because I think with that, Pentalateral is probably then one of the more advanced regions. And do you have some ideas on how we could then also basically try to make that known in other regions of Europe? Simeon.
Claude, you got me there with a difficult question indeed. I'm afraid it's hard to commit to a very specific date, and we are still sorting out a couple of organizational issues. It's a bit of a new territory because we are talking about a study where we also intend to get external support, and that needs a framework that needs to be ready to incorporate that, but we are on a very good path, and I would be optimistic to have something at least something very solid interim by this year. But that's just an indication where we're trying hard to get this up and running as quickly as possible.
Thank you for that. I have a question to Dolf, but before the question to Dolf, Guy and Jeremy, I heard that we have some interesting questions from the chat and the Q&A in the internet. So Guy or Jeremy, if you could bring up the question and maybe also direct the question to the speaker where it was addressed. Thank you for that.
Thank you, Claude. Yes, we had a lot of questions showing the interest of the participant to the presentations. The first question that I will raise comes from Jutta Paulus, and it is addressed to you, Simeon. You can also see the question in the chat, in the Q&A, sorry. Mr. Agerspiel, do you see the need for revision of grid allocation costs following the cellular app, where electricity with grid costs only for the levels it actually uses? This would boost decentralized systems. Is it right?
Thank you, Guy, and thank you for that very pertinent question. I think, I mean, generally speaking, it is very important that scarcity of resources are indicated, right? That actors can react to it. And I think this is specifically important also in the context that we're discussing today about a holistic approach and a systemic approach, where it is important where the specific location is, where resources are needed. And it is thus important that there are indications of this scarcity and the value of resources that people can react to and also valorize in terms of business models. And I think there are different promising approaches. So there's certainly many countries that are considering a revision of their grid tariffs. And I think this is for a reason, specifically to cope with increasing flexibility needs and the need to efficiently develop grids. There's also an increasing number of flexibility markets which are being tested as pilots so far. So I think this is another element that adds to that question and which should be deployed and explored further. And last but not least, I think it's also important to stay behind of the controversial topic of future market design options. I'm very happy, for instance, that NSOE has taken up the project a bit more proactively recently by proposing several market design options. And I would encourage basically everyone to stay behind this topic, which is a crucial determinant for lots of things that will be happening.
Thank you. Jeremy, your turn.
Yeah, thank you very much, panelists, for the very interesting presentations. We have a question to you, Mr. Götz, because you mentioned situations where you need to curtail electricity in northern Germany in order to make to transfer to an overproduction compared to the demand that would be located in southern Germany. So could you maybe remind us the rules on curtailment and why you make those choice to curtail renewable electricity and to call backup fossil fuels to step in order to meet the required demand?
Mm-hmm. Okay, well, the intention for us is to cure a situation where we have a failure situation which was not planned. And the methodology to cure that is shutting down an offshore unit. So you could ask, why wouldn't we consider shutting down a thermal unit? And the reason for that is relatively simple. So when we want to do that, we need to be sure that the unit was in operation, and we need to design, or we want to design, a concept which is basically sustainable. So if we would connect a thermal unit, the probability that unit is in operation when our failure occurs is relatively low, because we would expect thermal units to disappear during the next decades. And for the time being, we would expect that the thermal units are operating only a few hundred or thousand hours a year. What we couldn't do is, because the reaction time we expect is relatively low, short, so it's a millisecond reaction time we require, we need to connect a direct generator or a group of generators. So that's the reason why we have selected offshore wind, because we expect offshore wind with a high number of operating hours a year.
Okay, Claude, I suggest that we move on to the second panel.
Before that, maybe a question to Dolf. So I have the impression that we have supercomputers who can run the modeling. We have innovative ideas like the Nets booster. So I think we know where to go. But then we have this question also of permitting, but also of the broader public to understand, why do we need an infrastructure in that place and not in another place? So as Irina, do you have an advice on how we should go forward? And that will then bridge to our second panel, which has exactly also this idea that we need to broaden already in the planning phase to bring in a maximum of actors, because more eyes see better, but also to make sure that we have a broader understanding of all participants in society. Dolf, from your viewpoint.
Thank you for that question, Claude. I mean, the acceptance is absolutely critical. Naturally, there is a tendency in the energy sector to look at this as an energy problem. But the moment you start to put steel or copper in the ground, it's not anymore just an energy problem. And many other things come into play. You see the same with the offshore wind planning. It's not that the sea is empty. There are also many other uses of that sea, same acreage, and you need to find compromises in all these cases. So, I mean, this event helps, of course, but we need many such events, many types of dialogue to get to these solutions. And indeed, there's also a comment in the chat. I mean, it's very nice to see all these 2050 plans, but what scares me is what we need to do in 2030. That is, and that's where these planning problems become really critical.
Thank you for that advice, and thank you all panelists. I think that was very dense, very comprehensive. Thank you for your input. And then I will immediately move over to our second panel, where we will discuss how to include flexibility and assess market impacts in scenario making. So it's exactly how to broaden the community of who is involved in the planning. And for that second panel, I'm pleased to have with me today, and that will then also be the order of the speakers, Gerrit Kendler from ENTSO-E. ENTSO-E, who is the EU body of the grid operators, and which has now to plan for the end game for the 100% decarbonized system. Lisa Fischer from E3G. E3G has worked over the last years extensively on basically bridging between 1.5 scenarios, but then also the infrastructure, and were very instrumental in helping us also to get a good deal on this 10E legislation. Ariana is one of the leading figures in Brussels when it comes to energy efficiency. So what can energy efficiency deliver? Welcome, Ariana. Christian is really moving the Eurelectric from coal and nuclear over to renewables in a very fast speed. So welcome, Christian, to be with us today. And then I'm particularly pleased to have another host of our conference, so Thomas Östros, who is recently appointed Vice President in charge of energy at the European Investment Bank. For those who don't know Luxembourg, so the European Investment Bank, and Thomas, I probably see you from my office, because Thomas is only 250 meters across the street, which is the beauty of Luxembourg, is that we have here on this Kirchberg Plateau, we have the statistical office, we have also the European Court of Auditors. So I once said that de facto on Kirchberg, we have a lot of knowledge about how to drive the energy transition. So welcome, Thomas, also to our panel today. And we start with Gerald. Where is ENTSO-E? So I think it's probably one of the most exciting business where you can be today. You are so needed for the transition. So give us a bit advice and insight on what you are doing in these days.
Thank you very much for the introduction, and thank you indeed. It is extremely exciting today. And talking about excitement, I would like to start with the European Championship. And if you look at the successful football teams, what you see is they have their stars, they have their world-class players, and around them they put a very good team. And so even the world-class players have their weak sides, and they put a good team around them to have a strong team altogether. And the energy system is actually quite similar. If you look at the energy system, you see that electricity is really a world-renowned, world-class player. Electricity has some fantastic sides. I mean, it's strong in efficiency. It is the most efficiency energy carrier. And it also has a huge potential of renewable generation. So there are really strong sides. But when you want to put your team together, you see that electricity also has, I have to say, a weakness. And the weakness is, as soon as renewable variable energy like sun and solar go up, we need more flexibility, and the electric system is not so good at providing the flexibility needed. And this is where the whole team comes into play, because the other sectors, they can provide flexibility very well. I mean, we have batteries in cars, we have hydrogen, which is the only real seasonal storage system. So we do need all the different players. But as also instead in the introduction, I think planning the electricity center stays at the core. And then you have to place all the other sectors around it to gain the efficiency gain of the electric system, to integrate renewables, and to decarbonize the whole energy system. I think that is what the future is all about. And ENTSO-E actually did 2 exercises lately, amongst many others. One was we made several papers and presenting our ideas in regard to offshore, because offshore will be a future player. Offshore will have a huge potential and will be one of the cornerstones of the future energy world, as well as onshore wind, but offshore wind is going to be a big player, and solar PV, of course, is going to be a big addition too. And we also thought about how can we achieve this sector integration, the sector coupling. And we provided the idea of the MSPS, that is called the multi-sectorial planning support. What you can see there is that we are talking about multi-sectorial and supporting a joint planning, because we do have to do it all together, to have all together a team that can win a tournament, or in our case, reach climate neutrality. And I think it is very, very important, third point, that we have high consistency between the onshore planning and the offshore planning, because we need to bring the offshore wind power to the demand centers. It is not sufficient to bring it to the coast. And we have to integrate it truly into the system. And this is where those initiatives are for, to have a holistic approach at planning the future energy system. And now the 10E is coming up. And as ENTSO-E, we see that if you look at the draft regulation and the debate that is ongoing, we really appreciate some of the elements. For example, there are the articles about offshore planning, offshore wind planning, and looking at the potentials and looking at what kind of structures we are going to have. Are we only to have radial connections? Are we going to have hybrid connections? Are we going to have more mesh structures in the offshore grid? This is a very important issue. And I think to go into a more mesh system is the future. We also see the framework to support cooperation between the sectors beyond electricity is very, very important. As I stated with our idea with the MSPS, I think it fits perfectly into that picture. And then the other elements that's very important is transparent, inclusive stakeholder engagement. And that is important for several reasons. One reason is, of course, you want to have the buy-in, you want to have the consensus between stakeholders if possible. But there's an even stronger reason. If you talk about the many sectors, you see that most people only understand their sectors, but it's very difficult to understand the other sectors, let alone the interactions. So no one can do it alone anymore. You can only do it together. And I think it's really our objective to do this together with stakeholders, to learn from each other and to implement solutions that will at the end work. There's one point where we have to improve. We see that the methodologies, all the tools we use, they're extremely sophisticated. And again, in communication, we have to use a simpler layer so that everyone is on the same level and can actually understand what everyone is talking about. I think in this regard, we have to improve, and we have some ideas on how to do it. So good stakeholder engagement and good ideas for this are more than welcome. And a little bit on the critical side in regards to 10E, we are talking about the governance. And the governance is heavily debated. And we believe what is very important is a balance of power and a really balanced framework between the different powers. So it is the Commission on one side and politics also of the member states to set down the principles, to say where we're going. It is the TSOs who are doing the planning exercise. It's the ACER oversight. And so it is very important that all players have their role, but it should be balanced. Every player should have a certain role and every player should be in the position to fulfill it. And no one should be too strong and no one should be too weak in this context. So this is my very first quick intervention. I think the electricity system will be at the core of the future design of the energy system, and we have to do it all together in clear and transparent processes. Thank you.
And good that you make this comparison between Lukaku and De Bruyne, and then your role in the European energy system. So well done. Lisa, governance, that's one of your new hot horses, I would say. So give us a bit on what is your view to get this, let's say, larger, more people to sit together to do the best possible planning, which I think is also a precondition to get the acceptance outside.
Thanks, Claude, and I'm very happy to be here. And this conference is extremely timely. And then maybe just quickly to zoom out before I get to your question. Unfortunately, I'm not making a football link. I'm very impressed, Gerald. We've really seen momentum is globally growing. 2 years ago, the EU's moved to net zero. We've now got 2/3 of the global GDP covered by net zero targets. Just to say, there is momentum behind this. We're not on our own doing this. There is an increasing understanding, and really a lot has happened over the last months, if not weeks, of what needs to be done globally and how urgently we need to overhaul our energy infrastructure. So you will have seen the G7 putting out an quite interesting global infrastructure investment initiative, committing to phasing out fossil finance for coal and starting to think about other fossil finance. The IEA has set out a clear pathway and really enabling us to think about what that means to think big and think climate safety and what that means, be it about tripling renewables capacity, installation rates to 2030, peaking gas consumption by 2025 at global level, and net zero electricity systems by 2035 in the global north. So there is a lot of momentum. We have a much better understanding of what needs to be done, and I think we need to catch up in Europe. I've been very excited to see momentum in the UK and Europe on putting more effort on innovation on long duration energy storage, and Gerald mentioned it at the moment. That's a critical question. We always revert to hydrogen. There might be much more out there, and it's really important to invest in innovation here. But coming to the gist of your question, Claude, I mean, within all of this, the EU is not only expected to lead, but it really has an opportunity. It's about to present the Fit for 55 package, a potentially world-leading legislative package on deep decarbonization, and it can position the EU as an attractive market for energy investment. And that critically depends on setting high targets, but critically also depends on getting this governance question right and giving us the right tools to achieve those targets. And scenarios in that context are critical. I'll tell you 4 reasons why. Getting the process for scenarios right is important to make the most of new energy resources, including those that are not big kit solutions, so digital solutions, consumer-facing solutions, approaching energy infrastructure from a supply-side angle, mainly like we're doing at the moment still, and still not fully overcome by the 10-year proposal, is not sufficient. We can no longer treat demand as exogenous in this whole process. Demand is a critical endogenous variable in our scenarios and infrastructure planning, and that the process should reflect that. If we fail to do that, we are basically preventing competition and innovation. So this is critical. That's number 1. Number 2, we have to create critical options for decarbonization, such as hydrogen and CCS infrastructure. I think that's really important. We to do that well, we need to know where we most need them and by when, and when to sound the alarm bells if we know we're not making sufficient progress. And then we can put focused energy behind that. And that also then allows actors like the EIB to know where and when to invest and how to make the most of their money. That links to the third point, which is really, we should avoid overbuilding and maintaining unnecessary infrastructure. We know that over the past 5 years at least, electricity grid investment in Europe has been stagnating, while actually gas infrastructure expansion continued. That's the opposite of the trend we want in Europe. So let's fix this, and scenario planning is critical to that. And that means having the right actors at the table, but also having the science at the heart to really get the scenarios right, because we haven't been able to do so in the past. And then four, we need to learn fast in this process. We will make mistakes in our assumptions, in our scenarios. We will also have some successes and get it right. We need to have a live way of monitoring our assumptions. And feed that into decision making, like things like how well are we doing on building renovation, when, under what conditions can we really ramp up building renovation rates, and then that needs to feed life into our scenario building process. So we also need to have a much more dynamic process. So apart from adding stakeholders to the mix, putting science at the heart, independent science at the heart, we also need that sort of life function to monitor what's going on the ground, learn from that, and feed that back into the process. And let me maybe conclude by just lifting the gaze a little bit. We know that the current approaches at national and EU level aren't quite fit for purpose for tomorrow's challenge, but we've actually seen across the globe, but also in the EU, examples where states and regions are experimenting with new ways of doing scenario planning, or at least a subset of that. So in the US, we've seen states that use software to really establish the value of distributed resources in avoiding additional network spend. And I think that's a really interesting way of thinking about it, because that can keep the cost of the transition or sort of limit the cost of the transition. In the UK, we're seeing a live debate about separating system operation and network planning in order to really advance energy system integration. That hasn't been decided yet, but it's a live debate, and it's really interesting. They're talking about independent system operators as a way of really choosing what's the best infrastructure for what service we want to deliver to people. So is it the district heat infrastructure? Is it the hydrogen infrastructure? Is it the grid infrastructure? Is it the buildings themselves? We need to invest in the buildings. And then in Germany, we've seen an effort led by, I think, Dana, of creating an integrated, a one-off integrated energy system plan with much more stakeholder involvement than before. I think that's still underway. I'm not sure whether there have been results yet, but I think that's a really interesting one to watch. So innovation is happening on this. In the EU, we have an incredible opportunity now. There will be an independent climate council that can give us sort of that guiding framework for scenario planning going forward, that can also pick up some of those functions that I've outlined above, perhaps not all of them, but network planning can then flow from that overall keeping on track function and focus on key decision making that the Climate Council sets out. I guess we also have that whole discussion, and maybe others will pick up on that, but around the energy efficiency first principle. And I think that can really, building that into the scenario planning can really help us overcome that outdated supply side focus that we're having at the moment. So really thinking about how can we make that demand endogenous into our scenarios and really decide on whether we want to invest in networks or actually invest in buildings and digital. And so the TENI, the Fit for 55 package are live. We got to get that right now. I think that's a real chance to upgrade our sort of slightly outdated tools from yesterday and be ready for the opportunities of today and tomorrow, because it makes sense for the climate, but it also makes sense really for keeping bills to consumers as low as possible. Thank you very much.
Thank you, Lisa. I think so. I think I have a problem here with my microphone, but let's move over to next speaker, to Ariana. So and basically, I think I don't need to see a lot to say a lot from the last sentences of Lisa over to Ariana. So the importance of demand side, but then the question is supply. We know how to scenario it, to model it. So how do we model demand so that it can be a real reliable part of basically also making the energy system more efficient? Ariana.
Hi, everybody, and thank you, Claude, and thank you, everyone, for inviting the Coalition for Energy Saving at this event. My name is Ariana. I'm Secretary General of the Coalition. For those of you who do not know the Coalition, this is a Brussels-based organization that brings together businesses, local authorities, energy communities, and civil society organizations in support of energy efficiency. So, as you can imagine, my remarks will be focusing mainly on the demand side, this part of the equation, rather than the supply side. So, we have heard from previous speaker that, of course, infrastructure planning must be consistent with the climate neutrality goal. So, for our perspective, this means switching to a new approach that fully takes into account the contribution of demand-side resources, such as energy efficiency, but as well demand response in infrastructure development and planning. For too long, we have been seeing that demand-side resources have not been considered as a viable alternative solution to supply-side measures. They are still not fully regarded as a ready, deployable options that allows to eliminate wasteful and inflexible demand, making the overall system smaller, more flexible, and better equipped to integrate renewable energy. So the application of the energy efficiency first principle should really lead to this paradigm shift, whereby before planning new infrastructure and increasing supply, it should be a normal good practice to assess whether demand can be reduced first. So let me make this more tangible and concrete. This means, for example, as previous speakers have, Lisa has already mentioned, considering to renovate inefficient old buildings before planning new infrastructure to supply energy to those buildings. An energy that will be wasted anyway because those buildings are leaking. So I think this looks like a common sense approach. So an approach based on energy efficiency first will basically means that energy efficiency should be considered as a resource for the energy system that reduce the overall investment costs that are associated with energy production, distribution, and use. And this approach will ultimately benefit consumers because it saves money. I think we also need to bring into the picture the overall benefits for the society that are brought forward by energy efficiency investment. Those are reducing greenhouse gas emissions, improving air quality, reduce fuel poverty, creating local jobs. This means ultimately making the energy transition more attractive for all. I think this is the starting point, and your question, Claude, was, but how we make sure that we operationalize this concept in something that can be directly applicable. So let me give you 3 points for consideration. So first of all, to operationalize the energy efficiency first, is crucially important that demand of future energy use is not overestimated, but that correct and decreasing demand projection for energy use are fully integrated in any scenario planning. So we know that the EU has committed to achieve the EU climate neutrality goal. For that to happen, energy use must decrease and must decrease fast. An overestimation of demand patterns will lead to oversizing infrastructure and risk-creating stranded assets. The European Commission has presented last year in its impact assessment for the climate target plan its estimation on energy use aligned with a higher climate goal of at least 55% by 2030. So those range presented by the European Commission are on a 36/37% reduction of final energy use compared to 2030. And this compared to a current energy efficiency target that is of only 32.5%. As the Coalition for Energy Savings, actually, we even believe that higher reductions are possible, are feasible, and are cost-effective. And we believe that the cost-effective potential to reduce energy use in Europe stands at least 40%. Whatever this is the number, whatever is the number, it's clear that this energy consumption trajectory that reduce energy consumption by 2030 needs to be well factored in any infrastructure development plan, and the infrastructure needs to be calibrated to this increased overall objective. And let me make one thing clear: this is not about restriction. This is not about reducing comfort. It's the contrary. It is clear that the most advanced economies have decoupled GDP growth from energy use. And so that's possible. And once again, energy efficiency measures that are carried out in Europe, in the buildings of Europe, benefit directly consumers. My second point to operationalize better the energy efficiency first principle is actually to put in place and to conceive a reliable methodology that is able to quantify and even to monetize the multiple benefits of energy efficiency that I've just mentioned. So the possibility of correctly and reliably estimating these energy efficiency benefits, like, for example, how many local jobs will be created, what will be the reduction of the health budget in a country because of improved living condition in our renovated buildings. All of those benefits needs to be quantified, because this would allow a fair comparison between energy efficiency improvements and supply side solutions. This would also actually reduce the perceived risk of investing in energy efficiency, which in many cases is still perceived as a risky business, even if energy efficiency measures are based on existing, proved, reliable technologies that are available today at scale. And my third point would be actually to also introduce performance-based regulation that reward network companies with increased revenues when outcomes consistent with the clean energy transition are met. This basically would facilitate switching focus from prioritizing capital expenditures for network upgrades and maintenance to performance-based outcomes, such as improved reliability of the system, increased energy efficiency, environmental protection, consumer satisfaction, and also protecting vulnerable consumers. To do so, I mean, as already mentioned before, expertise from the demand side sector is needed to complement the work that is currently carried out by supply side stakeholders, and only with a fair and transparent and balanced cooperation between the two sides of the stakeholders, we'll be able to deliver a truly integrated and decarbonized energy system. So to conclude, acting today to ensure that the infrastructure of tomorrow is in line with climate neutrality means simply giving a fair chance to demand side resources, particularly energy efficiency, to compete on equal footing with supply side solution, and this clearly will make the energy transition more attractive for all. Thank you very much for this opportunity to present our views here today.
Thank you, Ariana. And then moving to Christian, who is running the Brussels office of Eurelectric. So Christian, you have basically the challenge of stranded assets. So in a world which moves so fast, if I just think about the RWE company, all the coal investments, which some criticized years ago and which will now have to go off. But then also, how do you and basically also the companies, your companies anticipate the market prices? We have seen that CO2, the EU ETS system is finally getting to where it should be. But then we know that in moments where we have a lot of sun, a lot of wind, where we have less demand, that we have this merit order effect. So how do your companies anticipate the transition, and then probably, so as we are here in an infrastructure conference, what role will batteries play, what role will electrolyzers play, and will that be a part of the story also where energy companies will invest into? Christian.
Thank you, Claude. I hope you can hear me. First of all, let me say that we're not crying a lot of tears over old assets. The sector is very committed to moving forward and is very excited about the vast opportunities that await the electricity sector. We call the 2020s the electric decade, because if we are to succeed with the climate targets that literally everybody wants, there's no way around a massive, deep, profound electrification of our energy systems and our societies. So as far as we're concerned, doubling down on climate action will mean that we will have an exciting, a roaring electric decade in the 2020s. Now, to your question about the prices, that's an important one, because the way we have structured the power market was based on an asset portfolio of dispatchable assets, and we're now moving into a completely different system where the vast majority of energy will come from renewable sources. We know they're variable, so that raises the question over flexibility, as you said, and also over how the prices will evolve in a system that used to be very different, and where there used to be fuel costs. How does this look in the new world? Now, I think it's very clear that with the investment challenge we're looking at, we need to ensure that investors have visibility on cash flows, and therefore we need to make sure that they know they get their money back when they invest in, for instance, offshore wind or other solutions. Because after all, we are looking at 500 gigawatts of renewables that need to join the grids over the next 10 years. That corresponds roughly to half of all the capacity that we have today in Europe. So we need to build half of everything in 10 years. It is an enormous challenge. So people need to be sure that their money come back. Now, then moving on to the dispatch and how the system works and the prices evolve, we think that there will be a downward pressure on power prices as a consequence of more renewables in the systems. And this is something that most people that know about power markets agree with. Now, we need to address this some way or the other. Let's say fluctuating prices in itself is not a bad thing, but what we need to make sure is that we don't have, let's say, a structural imbalance where we have negative power prices for a long time or something like that. That can potentially create a situation where the investments will not flow. So we need to look at that electricity market. We need to look at whether there are sufficient long-term investment signals as well to make sure that we get a new generation of dispatchable assets online. And I very much agree with what Lisa said. There's a whole range of different solutions to provide flexibility that we need to think of. DSR, integration with heating systems, hydropower, for instance, or rock storage. So let's go all in on hydrogen, but let's not forget about the other manifold solutions, and let's make sure that there's a level playing field and rules so everybody can bid into the market. What we're seeing right now is that the long-term investment signal for that particular and very, very strong focused push for investments is lacking. And that's concerning. And that's because, as I said, there is, let's say, a structural, let's say, downward pressure on power prices that we need to consider, and that we really need to reflect upon how we solve. I'd add two more things with regard to flexibility. And that's the grid dimension. Grids also provide flexibility. We heard a lot about the transmission lines that are needed. I talk a lot about the need for investments in distribution grids. Remember that 70% of all the new capacity will go on low voltage or medium voltage grids if we are to follow the European Commission scenarios, our scenarios, Wind Europe scenarios, or any other sort of generally accepted scenario. it's onshore wind and solar that are going to be the bulk of the new generation. We need strong distribution grids to make sure that we can handle that, because we also have the electric cars coming, the heat pumps, and all that needs to work in a more complex flow and in a different type of setting than the distribution grids used to. And therefore, when talking about scenarios, it's absolutely critical that we get the distribution grids properly represented in those discussions, and we don't forget about them or treat them as a subset of transmission, because it's a very, very different game. The world is going decentral. Crucial point. The last point I'll make is I was really inspired by what was said before by a few colleagues about this, the new approach to scenarios. I think we need that new approach, and I'm really, really thrilled to hear about it. More societal players involved, but it's not only about scenarios. We need a new approach altogether, one that overcomes, in my view, the most critical barrier for the energy transition, which is an artificial dichotomy between environmental goals and climate goals. There's a tendency to treat those in silos, and that there's not enough conversation about how we integrate solutions, both the physical solutions, but also the regulatory solutions, to make sure that this environment protection happens in unison, that we reach our climate goals, that we continue to protect the environment. How do we do that? New approaches needed, new conversation, new tools, and new planning approach, and a new conversation with citizens. That is needed, and I would really like many people here on this conference to be part of that conversation that we would like to initiate or reinforce. Thank you.
Thank you, Christian, for this powerful message. And then it's my great pleasure to hand over to Thomas Östros. EIB is a very sophisticated analyzer of what is happening in the European energy market. So what is your view on these issues like flexibility options, demand side, batteries, electrolyzers? And I don't know if EIB has also done some analysis on this issue of price volatility in the wholesale market, because you will need to hand over credit. So you need to understand what is the bankability of projects. So looking forward for your message, Thomas.
Thanks, Claude, and thanks for inviting me to this panel, and thanks to the panelists. Fellow panelists, I listened carefully to your very interesting introductions. I really like the analogy with the European Championships in football, especially since Sweden, my home country, is meeting Slovakia just in a couple of hours. So that makes this issue of playing well as a team even more pertinent from my perspective. There's really a momentum being built up on climate action in recent years. And we have, of course, COP26 approaching fast. And a lot of focus and attention is on the energy systems. We have a decade of needed action in transforming our energy systems. And I must say, the challenges and the opportunities are huge. If we calculate how much investments are required to achieve the targets, it will be around 400 billion euros per year during this decade for the energy and energy networks alone. To set that in context, this level of investment represents the entire EU recovery plan in less than 2 years. So this is massive. By 2050, widespread electrification of the energy sector and of the broader economy is expected to make electricity the dominant energy carrier, reaching a share of final energy use of over 50%. And then you should take into the consideration that in 2015, it was only 22%. The remaining needs in low carbon energy must be addressed through further measures, including with emerging innovative energy technologies such as batteries, storage, and hydrogen. Batteries are becoming the new heart of the automotive industry, and it goes very fast. while flexible sources such as battery storage, low carbon hydrogen, and demand response are integral parts of well-developed and efficient power grids. Driven by this increased usage in the automotive sector, costs of batteries have significantly dropped. Although we need further cost reductions for widespread use in the power sector, except for traditional backup applications. Indeed, grid-scale batteries, they are still a niche technology facing significant market barriers, with the installed battery energy storage in Europe remaining marginal. The rollout of projects will have to accelerate much faster to fulfill the battery's potential. The EIB has been supporting the battery industry in Europe for many years through significant finance operations in the development and manufacturing of lithium-ion cells and as a pipeline covering the full value chain. Going forward, the pace of investment is expected to accelerate. It is welcome to see more nations reviewing and removing regulatory barriers to allow for a level playing field for storage to compete with power generators, such as in capacity markets whereby storage operators can bid for contracts in auctions. Hydrogen is considered the missing link for long-term storage of energy and the new frontier where we need to move down the learning curve in the European Union. And the debate, as you all know, is lively and strong about the risks, benefits, competitiveness, and sustainability of low-carbon hydrogen. But such debates are not new. In the past, the EIB has been able to support many technologies in their early stage of development, and we can do the same for hydrogen. Low-carbon hydrogen projects still carry high commercial and implementation risks. Indeed, today, green hydrogen remains an expensive technology, and it is no surprise that H2 is costly given the hydrogen processes and associated inefficiencies. Moreover, only green hydrogen produced with renewable electricity is a zero-emission energy carrier and can help decarbonize the economy. And given the cost and limited supply, it would be more appropriate to focus on how to decarbonize uses where electrification is technically challenging, heavy industry, maritime transport, and potentially aviation. So the EIB has already contributed to low carbon hydrogen technological development with an overall lending of about 550 million euros to projects from 2010 to 2018 in the development and demonstration of hydrogen-related technologies. When it comes to financing hydrogen projects, the EIB keeps in line with the indications and activity-specific criteria and rationale of the relevant EU policies, in particular the H2 strategy and the Sustainable Finance EU taxonomy. It also applies the EIB banking criteria, of course, and it must ensure against the risk of loan default through proper risk assessment and proper pricing. The transition away from natural gas towards low carbon gas will remain a significant challenge for the industry, and a number of adequate market developments will be required. These will include a level of public support through subsidies, an adequate carbon pricing, and strict regulations on infrastructure, realizing cost reductions of production and utilization through R&D and large-scale deployment, realizing economies of scale in supply chains and widespread infrastructure. Finally, massive investment will be required in additional production of renewable energy. In this regard, several member states have announced very ambitious policies and made significant funding available. And the recent European Union hydrogen strategy published by the European Commission emphasizes the challenges and way forward. And we also expect significant EU funds to be dedicated to this topic. So to conclude, Claude, let me stress the importance of investment in energy technology. There cannot be leadership on climate without technology leadership. The current momentum is possible thanks to new technologies, batteries, storage, hydrogen, that will need to follow a trend similar to wind and solar PV in terms of cost reduction. The EIB can support investment at scale and thereby contribute to creating the market needed to foster technology deployment in these areas. However, for batteries and hydrogen to play a significant role, in the EU decarbonization, a number of adequate market developments will be required, from carbon pricing to infrastructure regulation. The bank is playing an active role in the European Battery Alliance and is working with the European Commission, the automotive companies, battery industry, and the Clean Hydrogen Alliance, aiming to support the market transformation required for batteries and H2 to play a role in EU decarbonization. And we see many challenges on the road ahead. Some of those were discussed in the panel. We see also great opportunities to good investments. And we are working with the solutions, and in many cases, we have already found the first steps to the solutions. Thanks a lot.
Thank you, Thomas. And I think it's really important to see that the bank has a very sophisticated, nuanced view on where, for example, hydrogen should go to, in order also to prevent stranded assets on that. I know that you will have to leave around 12, so we will try to speed up finishing this panel. I have one question back to Gerald. Landlocked countries are also interested to be connected to the offshore wind. And last week I have signed with Denmark, with Dan Jørgensen, a cooperation agreement so that Luxembourg can also participate in this visionary project of the energy island. So how do you at NSOE anticipate that? And not only for Western Europe, but maybe also for Eastern Europe, from Baltic Sea to Czech Republic is not further than from Baltic Sea to Munich, so to Baden-Württemberg. So is that in your modeling?
The modeling indeed is starting. I said we already presented several position papers, and now we're preparing ourselves to do the offshore development plan. The Commission asked to do it starting from 2050, so looking backward, moving forward, which really makes a lot of sense because you want to see in which area it is going. And what is very important from an NSOE's perspective is exactly to address the point that you said, to bring the energy to the end customer and also to integrate this with efficient uses. For example, we have to look at where to place the electrolyzers to have an overall efficient system. We also have to look which industries will decarbonize going to electricity and how we can make best use of this. So number one is we will make a long-term development plan on offshore. Number two, moving now from today forward in our TYNDP, the 10-year network development plan, we expect to take much more the stakeholders on board to have a clear view also in regards to efficiency and efficient end use. And we are moving in the direction from both sides.
Thank you for that. Maybe then a question to both to Christian and also to Thomas. So this volatility on the wholesale market, the modeling which is required for that, should we leave that to, I don't know, E.ON AVE will do it, Ørsted will do it, Enel will do it, but is that sufficient, or do we also need more, let's say, open source modeling to understand when is the market too volatile, and could, for example, electrolyzers and batteries in that moment pop in and absorb some of the volatility? So what is your best guess on how to advance on precise modeling so that on that issue? Christian, maybe first, and then Thomas, if you want to add something.
Yeah, again, my point would be that it's not necessarily the volatility that's a bad thing. So fluctuating prices in principle is a good thing. What is bad is structural imbalances. If we have more permanent periods of negative wholesale power prices, or too little capacity and therefore enormous prices, that's a problem. Now, the problem that we see is really, let's say, this lack of long-term investment signals and the visibility for investors. And that goes also for that new generation of programmable assets I was talking about. We're not seeing a huge takeoff in DSR solutions. We're not seeing a huge takeoff in storage. I mean, we're seeing now a push in hydrogen, which is really backed firmly by massive subsidies from individual member states. But in order for this eventually to become a business where people look at prices and make their decisions based on what they can get in terms of revenue, then we need a slightly different type of market design. And I think we need to start reflecting on that in a proper manner. I would personally welcome an open source contribution to that discussion. I think everybody will continue to do their studies because, of course, all the big utilities will do their studies. We will probably do some exercises, and the Commission should absolutely also do one, so to understand what are the impacts of these capacity additions, how will it impact price formation and the markets in general, and what should be done about it. So I would support an exercise that comes from many different sides, and then to compare notes on that basis. But we need that new market design in the 2030s at the very latest, and we should begin therefore.
Thomas, you mentioned the importance of markets for this kind of flexibility or storage. What would be your advice on how to frame that market so that it gets foreseeable?
So thanks for that question. I think I agree a lot with what Christian said. So volatility, we are quite used to deal with volatility. The basic issue in pricing, the basic issue is what is behind the price volatility. And of course, if we go into a development now with more decentralized energy supply systems and with more renewables depending on weather conditions, we could expect that we have a more volatile situation going forward. And then we have to deal with the basic facts behind that. How do we see to that we integrate energy markets in a way that we can balance it out, demand and supply in a more efficient way? How do we use new technology to have smarter grids that helps to deal with this type of more volatile energy supply and demand situation? All of these issues, and how can we deal with storage in a way that we also have market conditions and regulatory conditions that gives incentives to invest in storage and play a part in that balancing act. I think we see some tendencies in member states where they take steps to try to deal with this. And I think we are in that process to learn how we do it the best way. I'm not ready to say exactly this model should be used, but we should try to create market conditions that makes it commercially viable to contribute to stability in the energy systems. I think that is a key issue.
Thank you for that, Thomas.
Some questions?
And Ariana, maybe if you have to add something on the issue of modeling, I know that you want also the 10E regulation to be more focused also on this government issue, which is not yet in the text of the governments. But then an additional question, what do you think is the role of NGOs and think tanks when it comes also to helping us to get societal acceptance for energy infrastructure? Is there a role for them? Because sometimes, or can governments and TSOs alone basically organize societal consensus on that power grid infrastructure, on that cable, on that battery?
Well, thank you for the question, Claude. I think this goes back as well to planning and making investment, the infrastructure decisions that look at all aspects altogether. And I think integrating the perspective of different type of stakeholders, being, as you mentioned, civil society organizations, but also local authorities who at the end of the day will need sometimes to implement or that the impact of new infrastructure is extremely crucial, because this allows, on one side, to gain ownership of the new projects and of the new planning, and brings in a new different perspectives that is more closer to citizens, and that look at how enable participation of citizens, and also, for example, of local energy communities. So I think the more the merrier, as long as we can have more stakeholders coming from different perspectives to contribute to these scenario modelings with their expertise. This will only bring added value to the scenario making, and ensure that, again, the energy transition is participative and be supported by citizens.
Yeah, Lisa, final word from you.
Yeah, I wanted to pick up on the previous conversation around flexibility. I think what that really, the question it raised for me in my mind is, in the EU, we're still talking about having a gas package and a sort of very vector-based approach to organizing markets. I think in many ways we're now in a situation where we really should focus on what's actually the outcome we want to achieve, which is delivering zero emissions heat to people's buildings, delivering a market that uses all of its, that has, of course, a security of energy supply, but uses all the flexibility options out there. And so I just wanted to put this out there as a bit of a parting thought for everyone. Do we really need to rethink how we think about markets and frame markets to ensure competition here? And that also then links to how we connect with people and consumers, because I think at the moment, if you're on the gas grid, you're not able to choose across this range of solutions. And I think this is really the mindset change we need to achieve now, and it's critical to do this now, because we've been talking about this next decade as instrumental for our energy and climate targets. If we don't switch to a much stronger outcome focus and stick to our supply side vector by vector organization and way of doing things, I don't think we're making the most of our resources.
Okay, so I have one question from the chat, and maybe Guy, that you should go immediately ahead so that we could be in our timeline.
Yes, thank you, Claude. The question to Mr. Ostros, I will take you 2 more minutes. I'm sorry for that. You were talking about massive investment in the following years. Not only you, but many panelists have quoted that. Could you give me? Do you have any idea of how protect, and do you have any tools of trans-border investment protection tools for those investments? Should that go through legislation, through treaties, through financial instruments? What are the investment to all this investment? Thank you.
Thanks. Unfortunately, the sound disappeared a couple of times, so I didn't fully hear, but let me try to address, I heard the first sentences. So I'm basically quite optimistic that there is very strong incentives to do very large investments in the private sector coming after this period of the COVID crisis. What I see is an industry that realizes that the boundaries are there, and the goals and the targets on climate action, they take them seriously. And they have started really to calculate how will this transform our industry in the coming decade. And with this low interest rate environment, plentiful of capital available, EIB can play an important role in inducing this in the European Union. I think we will have a period of climate-related investment also in the private sector that will be quite impressive. Let me take an example of what is happening in the steel industry. When they seriously start to think about how to decarbonize steel production and take in hydrogen into their calculations, then we get a driving force that is very strong to develop technology and to push cost pressure on this type of energy storage. And I think that will transform industry in Europe if we do it correctly. And since EIB plays in all 27 member countries, we are very well placed to contribute also when it comes to cross-country investment in that respect. And I think this is what we're going to see, not least when it comes to the power sector, electricity generation, grid investments going forward.
Thank you.
Thank you very much, Tomasz, and thank you, to Christian, to Ariana, to Lisa, to Gerald. I think that was very dense again, with clear ideas where we should go with modeling, opening it up, having open source also for better understanding the market signals, and collectively creating a societal consensus on the energy infrastructure. Thank you very much for that. And now it's my enormous pleasure to move to our high noon session with the ministers, with the EU Energy Commissioner, and with somebody from an important body, which is the European Parliament. So we have, I think, set the scene. We know how to build infrastructure. We have had detailed thoughts about how the planning should go. And now we will be with Kadri Simpson. Welcome, Kadri, from in Brussels, with Claudia Gamon. Also, I don't know if she's in Brussels, but she is with the European Parliament in the team of those who negotiate, and which will help improve the already good text which we got with the governments. Then my pleasure to have Teresa Ribeira, the Vice President, one of the Vice Presidents of the Spanish government. She's behind the Pyrenees, and she has a lot of green energy. She has a lot of energy herself, but she has a lot of green energy in Spain and in her neighboring Portugal. So how do we bring that energy maybe to Luxembourg? And then, of course, René Nedela from the Czech Republic. And I think, for me, Czech Republic is a bit in a similar situation than Luxembourg. You have a big industrial base. Your renewables, okay, you are not the most competitive country when we compare to, I don't know, to Denmark, to Portugal, to Spain. And basically today we heard that one of the optimization which is possible is with grid integration, also bringing these kind of large-scale renewables to landlocked countries. And maybe René, it will be really passionate to have a debate with you. So thank you all. And then we will have a video with Dan Jorgensen. Dan unfortunately couldn't make it today, but he has sent us a video. I haven't seen it, but probably as always, Dan is very inspiring. Let's start with Kadri. So you have put on the table the 10E legislation. You were in the room when we had this nice Friday in Luxembourg last Friday. So where do we go from there, Kadri?
Yes, good afternoon, Claude, and dear panelists and ladies and gentlemen. Indeed, last Friday we had a very important meeting at Luxembourg, and I was so pleased that we came out from this room with a general approach on 10E proposal. Because, well, when we speak about renewable energy in Europe, we actually mean an entire competitive ecosystem, and it starts from the manufacture of components, but spans to grids and culminates with valuing them in use. And in this regard, the effect of the transition is also a not only European one, but also international one, because this will forge us in collaboration. And well, from the position where I'm speaking, you know that we are working as the guardian of the treaties. The European Commission safeguards that the process evolves in an orderly and fair manner. And so you have designed from our side policies that are instrumental in bringing down costs for renewables in the past decade. And And now, as regards the needs of our future energy system, our focus will need to be on a significantly higher share of electrification. And of course, renewable production, both onshore and offshore, and as well as shifting our focus also to hydrogen infrastructure. So new built renewable power generation, we know, is now often cheaper than gas and coal power plants. And according to the impact assessment that was accompanying climate target plan, we know that wind energy will be the biggest energy source already by 2030. And most of the installed capacity, of course, will still be located in onshore, but we will witness that offshore wind will be growing very fast. So when we adopted last November our offshore renewable energy strategy, then we set very ambitious targets, both for 2030 and 2050. And of course, a specific action, how we will reach them. And the focus areas are maritime spatial planning, again, creeds, and then, of course, market framework, but as well, industrial value chain and jobs and research and innovation. All these are very necessary. And we are at the point now where we can agree that maritime spatial planning is key to the development of offshore renewable energy. And this is because of the various economic activities taking place there. Well, there are older economic activities such as fishing and transport and military and tourism, and the sustainable management of maritime space is paramount because we need also public acceptance of offshore wind generation. And in this regard, we know that member states are doing their part. So they have submitted their first national maritime plans, and they did this spring. And I hope that over time, these maritime plans will be better aligned with the national energy and climate plans. Because right now, I have to admit that member states find themselves in different situations regarding access to renewable energy sources. Well, of course, in particular, offshore wind, but their regional cooperation is essential because it helps us to ensure security of supply and developing trans-European energy infrastructure in Europe. So, of course, we are privileged to have strong regional cooperation mechanism in EU, like the North Sea Energy Cooperation, and it promotes offshore renewable energy. And then of course, in the future, cooperation on grids, including hybrid projects and long-term grid planning, that all are necessary to decarbonize our energy system. And then, of course, I want to mention another cooperation alliance. This is Pentalateral Forum that also continues its support. And then we have to well admit that that infrastructure is the backbone of the energy system. In this regard, the agreement that was found last Friday is essential, helps us to start negotiations with Parliament already this year. And I hope, Claude, that later on you will have questions regarding 10E proposal or something else. So with that, I will conclude my very long opening remarks because I really want to listen what ministers and MEPs have to say. Thank you.
Thank you very much, Kadri. And then over to Claudia. So where are you in the European Parliament, and when can we expect basically a position so that we can finally start to negotiate? And you have probably seen where we came out as governments, and where do you expect that the Parliament will maybe be more ambitious than the Parliament? Claudia.
Well, thank you very much, Claude, for the kind invitation. It's a great honor to have the chance to speak among such distinguished guests. I'm on my way to Strasbourg, and I thought it might be a little bit fun to try out energy infrastructure in practice, which is why I'm coming to you from an electric vehicle charging station somewhere in Switzerland. to try out the European energy markets in everyday life. So my name is Claudia Gamon. I'm an MEP from Austria, and I'm working on the 10E revision in the ITRE committee as the shadow for Renew Europe. And it's been a very interesting journey so far, because to me it is clear that the 10E regulation will be one of the key instruments of the energy transition. It's such a fascinating file to work on. And we are having some of the debates that will be obviously relevant to many of the other legislative reviews that are coming up also in the Fit for 55 package. So many of the debates that we're seeing right now, I think, will be mirrored in the coming months. And really, I think it's clear to me that apart from the climate and energy targets that we have committed to, infrastructure will be a crucial point in actually making them reality in the energy transition. And it's due to the changes in our power system as a whole that we are undergoing. We will need more flexibility in the energy system. It's just due to the different nature that renewable energy sources bring to us. It's a completely different system of how we produce our energy and how we distribute it. I think this change, it's a paradigm shift from a centralized system to a decentralized supply, and that will change many things in the infrastructure, but also in the way that we handle it. And the 10E revision has to reflect that, and it's kind of the door opening up to the new renewables-based decentralized energy system. Infrastructure development and generation have to go hand in hand, and this is also true, and that's one of the very important points of this 10E revision, that is onshore and offshore energy, that I want to just say a couple of words to. Those are very, very crucial aspects of the proposal, and I'm really, really pleased that offshore grid planning for the integration of offshore renewables are addressed in the proposal of the 10E revision from the Commission. I personally would go even further and integrate that into the 10-year network development plan to really ensure coherent development of onshore and offshore grid planning. I think we should also focus more on the transmission to landlocked member states for consumption centers, or also to storage facilities. And that is, and I want to spend a little bit of time on one of the very interesting points that have a lot more potential than they are right now in the proposal. That is the offshore one-stop shop, to be referred to as one-stop shop, just to make it a bit shorter. For the sea basin is an important step to integrate offshore energy into the European grid. It is a unique point of contact for the project promoters. It's a joint responsibility for facilitating and coordinating the permit granting process. And there is a focus on knowledge sharing. However, while I really appreciate the point in data sharing, I think that's very important, obviously. I think that the role could be even stronger. It could be an example of what we actually mean by really unlocking the potential of infrastructure development for renewables in all of Europe, because permitting is actually one of the main reasons for delays in these very important infrastructure projects. But I don't think a project will necessarily be accelerated if we add another structure on top of the national administrations with no real added benefit in terms of permitting. So it could lead to a situation where a project promoter has the one-stop shop on top of 5, 6, 7, or 10 national ministries, depending on how bureaucratic your national member state is. So I think it should be the goal to cut red tape, because in my talks with stakeholders, permitting and just the length of these processes has been a very important point. And because, Claude, you asked about what do I expect also from member states? And I know that when it comes to permitting and the processes that they have with their own ministries, it's a very important point. But I think this could be an example where we can work on together to really say that, you know, Europe is not just only added red tape, it's actually cutting red tape. It's making it more efficient. It's really trying to find synergies in our development, especially when it comes to topics such as an integrated energy system. So this is a window of opportunity to use this. And I think this is just one of the highlights, of one of the many highlights of the 10E revision, where we could really achieve something that could act as an example of how we can do it also in other regulations. So really just a final remark, I really appreciate the ambition level that was put forward by the Commission proposal, and I really hope that we can keep it up and keep up the innovative spirit also of trying to think in new ways. But for me personally, the most important point is that 10E really reflects the paradigm shift in the energy system. As I mentioned before, how can we really facilitate this transition to a decentralized production and supply? That's my most important point. So thank you very much.
Thank you very much, Claudia. And then to Over the Mountains, Teresa, what are you doing in Spain? What do you expect from 10E? Go ahead, Teresa.
Thank you so much, Claude, and thanks to you all for this very interesting dialogue on something which is very important. I think that interconnections is a must if we want to ensure an efficient and well-performing energy system that facilitates that all the green renewable energy we have to introduce into the system in order to favorize the decarbonization of the economy can take place at the smoothest way. I think that the needs for the grids and the distribution systems are changing very deeply. We need them much more smart and intelligent, and at the same time, much more capillary, but facilitating a well interconnected world among the different countries in the European Union. This is the best manner to combine the modernization of our economy and our energy system with a well-performing and facilitated way forward. I think that this can facilitate the security and continuity of the electricity supply. It can improve the efficiency of our energy systems, but it can also facilitate a much more well-functioning market. So to ensure that the prices do not come up at the highest level, at the craziest level, and difficult the confidence of the consumers on the benefits of the energy transition. And in doing so, we have to play a relevant role as regulators. Of course, the Commissioner, the European Commission, and the European institutions, but also at the domestic level, together with the different players that have a role in this energy transformation. In our case, when talking about your very concrete question, Claude, the main concern for Portugal and Spain is the very low level of interconnection with the rest of Europe. And for a very long time, probably because there were some countries, and in particular our very good neighbors, nice neighbors, France, that thought that it was something that it was not so relevant for them. But I think that as far as the energy system changes, France will also benefit from this interconnection from the south. So to facilitate that whenever they have a problem, the electricity being generated in sunny countries like Portugal and Spain can facilitate an alternative to their own system. You know that Portugal and Spain, but in particular Spain, because with Portugal the interconnection is with us in neighboring countries, is far, far, far away from the minimum 10% of interconnection that became something demanded for all member states. We work with France in bilateral terms, and of course with the support and the understanding of the Commission to accelerate and overcoming the technical challenges and to do it in a manner that it is socially acceptable, environmentally acceptable. But this is something that is still in the air, and we still need to work very intensively. I would like to point some additional points which are relevant. We want to achieve 74% of our power generation being renewable by 2030, 42% of our end use of energy being renewable. And I think that when talking about interconnections in Europe, we need to bear in mind that the challenges are changing slightly. We need to improve, to promote the capacity to become fully decarbonized, so to be very cautious on interconnections that may provide a new support to new fossil fuel energy. I think that the main question marks right now are focusing on these new challenges. So, for instance, how we interconnect with islands. In our case, with the Balearic Islands, this is expensive, but it is happening. It's much more challenging when talking about the Canary Islands, or it is more challenging if we talk about maritime interconnections with other countries in Northern Europe, or with Ireland, for instance. The second thing is, what does this mean for the growth of the offshore energy, and to what extent this is posing new questions. For instance, last week we were talking about this very interesting initiative being pushed by the Danish government, but how that can provide offshore wind energy to other countries that are not Denmark, and how does this fit in the new mapping of these interconnections. Add to that, how we intend to transport the green hydrogen, and add to that, I would say, which is pretty interesting and probably something that is better understood by the island states, or because of this difficult interconnection with France, by Portugal and Spain. What about storage? Storage to facilitate and to reach a level playing field there where the interconnection seems to be a little bit more difficult, but has an impact in the European market and in the European physical question marks on how to ensure a very well performing electricity market. So I think that this is fascinating, evolving, changing. I think that we can provide very good signals when we do so, and when we look consistent. This is also an interesting appeal also for the private players in this field. So investors and developers that do understand and do try to assess to what extent what we do, what we do makes sense, or to what extent there are still some inconsistencies we need to clarify. So I think that this is challenging. The Commissioner Simpson is making a great job, sometimes not very easy, because we have different backstories. I mean, I think that each of the member states has a different background, and we need to combine all these differences in something that makes sense for all. But my main message would be, it is time to converge and to try to identify what type of future we want to build in a context where the green recovery is probably the best news for a common project in Europe. Thank you, Claude.
Thank you, Teresa, and then immediately over to René. Czech Republic, as a former powerhouse of Soviet Union, still a big actor in the electricity field. So where do you see challenges, and for example, this option of bringing also offshore wind to Prague, is that an option you, or from the Black Sea, is that an option you are considering? René, pleasure to have you.
So first of all, good afternoon, everybody, and thank you for inviting me to this conference, which deals with a high topical issue of integrating renewable energy sources into the grid. Let me shortly comment actual situation in Czech Republic. The Czech Republic, and you already mentioned, is a landlocked country, and as such cannot directly benefit from the development of offshore energy. Also, other forms of renewable energy are rather limited. The Czech Republic does not have high mountains, wide rivers, and it's not a significantly sunny country. But currently, we are preparing first calls for the development of renewable energy sources from a modernization fund. And it's not only the support mechanism, but it is probably the most important given the amount of available funds we think. The interest of the potential investors is very, very high. In the pre-call, it was indicated interest on the level of more than 20 gigawatt installed capacity of photovoltaics. Now the actual capacity is 2.2 gigawatt. The integration of this amount of solar is, however, challenging, even though the Czech Republic is highly meshed. We are thus currently discussing with TSO and also DSO how to safely integrate it as much intermittent renewable energy sources as possible. We are already working on this for a number of years under the National Action Plan for Smart Grids, which we have. Czech Republic also appreciates the establishment of the renewable energy financing mechanism on the EU level. This mechanism enables, in our opinion, even the landlocked countries to participate on the financing of the development of offshore energy. Czech have not indicated participation in the first call because we would like to develop our national potential of renewable energy sources as much as possible, since we think that the regional decentralized renewable energy sources has other benefits on the top of the energy production. But we, of course, welcome to this opportunity to use this mechanism if needed. Let me also mention one project. This project is called ACOM, which is the first project under the CEF funding focusing on smart grids. This project is developed by the Czech Republic and Slovakia. It is a project between Czech DSO EGD and Slovakia DSO Západoslovenská distribučná, and also there is a participation of Czech TSOs, CHEPS and SEPS. And we think that not only extension of grids, but also development of smart grids is very important. Nevertheless, the challenge is not only about the production of electricity, but also about the transmission of the energy to the regions where the demand is allocated. Development of offshore energy must go hand in hand with grid extension and its modernization. In this regard, we think that Czech, which is already an important transit country, might play a crucial role. Czech already has interconnectivity level of 30% and is planning further increase of capacity of interconnectors. Now, I would like to say a couple of words about the foreign exchanges and their impact on the Czech electricity system. Due to geographical location of the Czech Republic, a large volume of foreign exchanges is carried out through it. In future, the volume of these overflows will depend on the ability of the surrounding TSOs to eliminate surpluses caused by renewables. The Czech Republic assumes a massive development of renewables of approximately 4 to 6 gigawatt, an increase of 200 to 400% by year 2030. Therefore, in the Czech Republic and in the surrounding countries, it is necessary to focus on interconnectivity and this regional to the strengthening the cross-border capacities in a coordinated manner. And that is crucially where I see the role for 10E and PCI projects. Let me give you some examples of transit energy where the Czech Republic, just for clarification how it is. I mean the difference between the planned and actual flows on interstate transmission profile. The large transit we experienced in 2020 was on Austria profile. The planned flow was 0.2 terawatt hour of import, but the actual flow was 8.3 terawatt hours of export, so totally opposite. The profile with the second highest transit is the Polish profile. In 2020, the planned flow was 2.9 terawatt hour of export. However, the actual flow was 2.3 terawatt hour of import. On the profile with CEPS, with the Slovakia Republic, The high planned export was 10 terawatt hour, more or less corresponds to reality. Transit from Germany to Germany, flowing from 50 hertz through CHEPS to TNET represents 7.2 terawatt hours last year. Next issue I would like to mention is the cost to development of RES will bring along. The NSOE 10-year National Development Plan of 2020 identifies these system needs. By 2030, additional 50 gigawatt of cross-border reinforcements would be cost efficient to support the electricity system. Decarbonization by offshore projects requires not a negligible part of these capacities. NSOE 10-year National Development Plan 2020 expects 250 gigawatt of offshore capacity in 2050. This cross-border capacity increase 50 gigawatt represents about 17 billion euro of investment in the European transmission. By 2040, 43 gigawatt of additional cross-border investments on top of the increase identified for 2030 would support the evolution of the electricity mix in the generation of decarbonization. In general, changes in generation mix and movements of generation centers will require not only capacity for their connections to the grid, but also additional cross-border capacity among European countries. We must keep all this in mind when we are planning the development of the renewable energy sources. So, thank you.
Thank you, René, for that very detailed assessment where you stand and how your country could, in a certain sense, be a bit the center of the balancing for Central East and then also the bridge to the Central West power market. And I think I would be delighted to follow up this discussion. Now we will have not live, but through video from Copenhagen, Dan, and then we will have a quick round of questions. But now, Mr. Energy Islands from Copenhagen.
Hello, everyone. Thank you for inviting me here today. And thank you, Claude, both for hosting and for your commitment to offshore energy. With our bilateral memorandum of understanding, you continue to demonstrate your strong support for the Energy Island project. We are excited to partner with you in shaping the development of offshore wind for decades to come. The EU has set a bold goal, expanding Europe's offshore wind capacity from 12 gigawatt today to 60 gigawatt by 2030 and ultimately 300 gigawatt by 2050. That is 25 times more than we have today. Or to put it differently, each year until 2050, we need to build almost as much capacity as we have in total today. So we need game changers. That is why Denmark is driving a true paradigm shift in the way we build offshore wind. Traditionally, we've seen a national approach based on regular offshore wind farms sending electricity home to domestic shores. But we want to go beyond national borders. We want to share our green energy resources and to allow energy to go where it is needed the most. That is the concept of the Danish Energy Islands, a concept that we believe can serve as a model for the rest of the world. To go beyond national borders. We want to share our green energy resources and to allow energy to go where it is needed the most. That is the concept of the Danish Energy Islands, a concept that we believe can serve as a model for the rest of the world. The Energy Islands will function as central hubs, collecting and distributing wind power from several surrounding new offshore wind farms to European shores and potentially to other hubs established by other countries. And I'm proud that Denmark is building the first ones. One in the Baltic on the island of Bornholm, the second one in the North Sea, which will be in the shape of an artificial island 80 kilometers offshore. Together, they will have a capacity of 5 gigawatt at first. Eventually, they can be expanded to reach a total capacity of at least 12 gigawatts. That is enough to cover the electricity demand of 12 million European households. Now, this expansion of power generation can also enable expansion of green hydrogen to provide energy to sectors that are difficult to electrify, such as heavy industries and transport. This approach will truly be a game changer in the European fight against climate change. But it all depends on our efforts to build an efficient trans-European infrastructure. Since its adaptation in 2013, the 10E regulation has shown itself to be an efficient tool for leveraging investments in energy infrastructure across the EU. Many of these investments have been in natural gas. As we look ahead to the future, 10E can play a crucial role in building a green pathway to achieve EU's climate goals. To support the offshore energy hubs in particular, let's prioritize transboundary power grids. This is the path that will help enabling further cross-border integration of low-cost renewable generation. For example, let's focus on new green power corridors connecting offshore energy hubs with load centers in Central and Eastern Europe. By taking a regional approach, we can ensure that we reach the full potential of the energy hubs. I look forward to continuing the collaboration with all of you. We know that our energy and climate challenges are too large to any single country or sector or organization to solve alone. By pooling our collective energy, passion, and resources, I know that we will rise to the moment and meet this challenge. Thank you very much.
Thank you, Dan. Dan was fantastic. He even these small breaks and where he was frozen, he got over. So thank you, Dan, for that. We have one question from the chat for Kadri, and before that, I may add another one. In our last panel, the question was raised about basically environmental legislation, biodiversity protection, and then on the other hand, the fast rollout of renewables which we need. How do you approach this inside Commission between the different commissioners? Have you started work to look on how that can be accommodated? And then maybe Jeremy, quickly, the question from the chat. Jeremy?
Yes. Hello. Thank you, Claude, Commissioner. We have a question actually from Mr. Žygimantas Vaciunas, the former Energy Minister of Lithuania, and he's taking the example of the manufacturing of PV cells and modules, where the EU lost some time ago leadership towards other parts of the world. And if I may allow myself to broaden the question, we speak a lot about offshore wind, we speak about batteries, we speak about electrolyzers, copper, steel. How about keeping the industrial value chains within Europe? How about building a strategic autonomy for the European industry of those sectors to thrill and to be able to supply the whole transition with requested technologies in due time?
Thank you for the questions. Yes, thank you, Claude. Thank you, Claude, for your question, and thank you, Žygimantas, for your question. Well, to start with the question how we coordinate different legislative proposals that are coming from different directorates. Well, fortunately, we are working in the principle of collegiality. And this is very necessary when we are addressing the topic that Claudia also mentioned, that permitting takes a lot of time. And well, definitely this is a time-consuming procedure when you are planning new offshore wind parks, because as I was mentioning, there are older sectors, well, economic sectors like fisheries or shipping or even military, but there are also environmental concerns. And in this regard, Denmark is a very good so-called laboratory for us, because they built their first ever offshore wind park already 30 years ago, and still they have to consider different environmental restrictions. Well, if to name just one, then Birds Directive definitely is important directive that every project promoter has to keep in mind. And from our Commission side, we try to accommodate those economical necessities, and of course in the way that environmental concerns are taken care of. Now about losing European leadership. We do know that solar panels, most of the solar panels that are installed, they are, many of them are not produced in Europe. But even there, the situation is starting to change, because you can offer to the consumers more advanced solutions. And in this regard, for example, roof tiles or solar installations that replace also the roof material and that are uniquely designed for exactly this building are already solutions that are coming from Europe again. On offshore technology, we are still keeping a very strong global leadership. Vast majority of the offshore wind installations that are built around the globe are produced here in Europe. This is a European know-how, and we try to safeguard also our leadership position for electrolyzers. And this was actually one of the reasons why when Commission proposed a revision of 10E, we also took on board at least 100 megawatt electrolyzers, because they will have cross-border impact. So far, these kind of projects have been financed from Innovation Fund, from funds that were dedicated to research. But the technology is here, and now we have to create existing clean hydrogen market, and this is the reason why we also thought that that 10E as a proposal that will help us to build up backbone of the energy system should cover also electrolyzers. Thank you.
Thank you, Kadri, for that detailed response. One question to René before moving to Teresa and to Claudia. We have this in Southeast Europe, we have EU member states, we have non-EU member states, and personally I think that one of the next big tasks in the integration of power markets in Europe should be trying to have that market a real cross-border market, probably even with, also with the non-EU countries like Serbia being a part of it. Today I know that there's tensions because Serbia is outside ETS and it can bring in coal-based, non-priced electricity and basically push out of the merit order power stations in your country. So how do you see what should we, isn't it one of the priorities beyond infrastructure to work on this kind of Southeast European power market and to give this a higher priority in the next years?
Thank you for this question, Claude. I think, when I look how it is the situation now in the Czech Republic, when we are discussing coal phase out, now we have, 22 capacity, we have installed capacity 22 gigawatts and more than 10 gigawatts is in coal. And we are discussing, how to replace coal. So the coal. Then my answer to you is that in Czech now the priority is to find a solution how to replace them, and how to build new energy sources and renewables. And in Czech we are also discussing to prolong our existing nuclear power plants, and also we are trying to build new nuclear power plants because we would like, to reach the target with climate neutrality. So then my answer is that this is a priority and not the priority of market integration also from EU member states. Even I know that there is a big discussion about competitiveness of Europe, and it is what you mentioned, that you can buy some product from non-EU, and the product is much cheaper because they haven't got ETS allowances, So you are also right that this question is on the table, and in a longer future, for sure, it will be good if we will integrate also non-EU member states. But now, for example, Czech, we are discussing how to replace existing fossil coal energy sources by gas, biomass, renewables, and other technologies. This will be the priority, because we will have a problem with enough energy in Czech Republic in the future.
Thank you, René. Then back to Teresa. You mentioned a possible cable between Ireland and Spain, but when coming back to what is between this Spain-France dilemma a bit, because I sometimes hike through the Pyrenees. It's not so beautiful to have pylons when you are hiking, but you have this experience from in the Biscaya Sea, where you have built a cable which has been financed by Europe. So isn't part of your story maybe the common story with France and of Europe to integrate the offshore wind floating technology, which will be, I think, the next big game changer? When you look, where do surfers go? They go to Le Cat, which is south of Montpellier, and that is 20 kilometers from the Spanish border. So wouldn't be a cable linking Spain and France and then typing into floating? And also on the French side, you have already a lot of, it's a hotspot for onshore. Isn't that maybe a possible breakthrough, which is more likely than pylons over the Pyrenees?
Yes, I think that this goes very much along the direction we need to push. It's true that sharing some maritime spaces is an interesting way to foresee common solutions, and this can happen both in the Biscay Gulf and in the Leon Gulf, so in the Mediterranean and in the Atlantic. It is socially easier, and probably the wind is stronger in the Atlantic than in the south. In the Mediterranean, which is much more populated in the coastal areas and with much more activities that may raise some concerns. But I think that this is an interesting approach to see to what extent the interconnection between countries, between member states, can also facilitate the interconnection of the offshore islands, such as Dan was introducing in the case of Denmark. And I think that this is very interesting. I think that for the time being, the long distances show to what extent it is still probably an expensive adventure. But I think that this is something to bear in mind, as it is in the case of the interconnection with islands as such, islands. In fact, we are very much in favor of the project of islands 100% renewable. So to use our islands as a very interesting window to the rest of the world. We can achieve this very interesting goal in islands that are the most favored islands of the world, because I think that the European islands have this status. And to do so, of course, taking into consideration that the available surface for renewable energy is very limited, the interconnection to the inland spaces is key. We have advanced a lot in the case of the Balearic Islands, as I was commenting, and the interconnection between the different islands, so to facilitate a better functioning, but still we need some transitional switch into gas, because it is the these are the places where we consume much more, how to say, CO2 intensive fossil fuel solutions. But I think that when talking about the interconnection between different member states, the fact of introducing an intermediate platform with offshore is an interesting approach, so that we can not only provide security of supply and a much more stable production of power, but also adding power into the system thanks to the offshore solutions.
Thank you very much, Teresa, for that. And a last question to Claudia, and then we will close this panel. So what do we as governments who have now a position, what do we expect from the European Parliament? So, and I heard that governance is something which Parliament might be much more detailed and explicit. Is that one of the, so what will be the 2-3 basically key areas where we will have to, or where you will differ from the Parliament's position, from the government's positions?
It's an interesting question, and I can't answer it completely because we're not there yet. We're taking it step by step in the negotiations, which I think is a good way, because there are so many diverse types of debates that we will need to have. Because I mean, there's no sense in beating around the bush. Obviously, there are different opinions about whether or not and how to integrate low carbon energy, for example, but that is a debate that we have seen even before TENI, obviously, in this legislature. There are different opinions also about governance, which is where we are currently also talking about very intensely. And I do think that one of the points that the Parliament wants to make is to find, on the one hand, a process that is a little bit more structured, but also simplified, and a process where we can really, really say that the decisions that are taken are not biased. And to say one sentence about that, why I think it's important, I think that credibility is one of the main variables to success in the energy transition. So nobody should think that any of the decisions are not based in science or reason or fact and logic, because if there would be a scenario where the stakeholders and also the citizens of Europe would think that any decision is biased because of other factors, then we would have problems with our credibility. So governance is a very important topic, I think, for TENI. And then, obviously, as I said, there are many, many other a bit more politically controversial topics that we will get to, obviously, in time. And I'm really looking forward then to the trilogues, because it is such an important file, and it's important that we get it done rather better soon than later.
Thank you so much, Claudia. Thank you, Teresa, for having been with us. Thank you, René. That was really very interesting to have you. And I think we need this kind of also discussing from the different perspective, and a very big thank and hug to you, Kadri. It was an honor for us to have you on our conference. And I hope that it was interesting for the participants, and we will now go to the final closing session. So my part is almost done. I have spoken already a lot. I think it's about being cross-border, more open source models, more open to stakeholders. And then I think let's not underestimate the industrial policy dimension. And we speak about solar, so Meyer Burger is coming back even with the basis of solar, the cells coming back to Europe now with heterojunction, which is the next basically frontier. And let's also talk about the industrial policy dimension of grid transformators, because there it's also an issue of cybersecurity. So I think that we need also to have that on our plate and at work on that when we go for the energy transition. But now another statement from Francesco. So Francesco, what do you take away from this morning. And then Ambroise from the European Investment Bank will be with us. So Francesco, please, what is the essence of what you got from this morning's discussions?
Thank you, Claude, and it's been a very interesting discussion. If you allow me, I wish to share and compare what are the results, or at least the main key points that we are realizing in our work with our membership, especially when we talk about the long-term energy scenario, where everyone, I think many of our speaker has made clear we have to work on this energy transition network, looking to the future. So, we have been working with our country on this long-term energy scenario, where we have more than 25 countries now and 50 practitioners on energy generation and infrastructure planning. And as you can see, the conclusions are very similar to the one that we can come from the discussion today, and showing how European Union is leading in this respect. So first, integrating power infrastructure development with energy sector planning, coordinating efforts between energy authorities, transmission system operators, and the electricity industry is key. I think this has been already in the first, keynote speech that has been coming from the academic, how important is this, all these links. And also on this respect, many has been mentioned to this point. And so what is proposed in Europe, the revision of the Trans-European Network for Energy, including offshore grids, is very much in line with this. Coordinating different time horizon is also important. This has been mentioned. For example, China has a long-term plan to decarbonize the economy by 2060, but this is complemented by shorter 5 years plans on implementing for energy sector. So trying to monitor the progress in respect of the long-term goals. Third, accounting for innovation development is another key element. Has been many, as I mentioned, talking about green hydrogen, how the solution has to also to come from a kind of working in innovating the actual way to produce, distribute energy. In US, the NREL informed the national planning on the potential technology disruption relevant to national energy strategies and the current expectation of the number of years until they penetrate the market for good planning purposes. So it's very important when do planning also to understand how the innovation can bring us to progress. And finally, including participatory processes. I can bring here the example of Chile. Everyone has talked about social acceptance. So in that experience is that the Minister of Energy there incorporates citizen participation in every step of this long-term energy planning processes. This brings me to my experience under the Aarhus Convention. And as I mentioned in the opening, we have many of the solutions we need to make a decided shift towards a more sustainable future today. Our full World Energy Transition Outlook that will be released on the 30th of this month not only looks at the technologies, but also has been mentioned here. So not only the investment needed, but also the socioeconomic footprint and opportunity in the transition to a climate-safe energy system. So markets, socioeconomic impact policies are absolutely relevant as technologies. And this also, I think, came from the discussion we had today. It provides a clear pathway, the veto for the future, and we now need to work to make this a reality. In close, I would like to know that the discussion today has been very, very interesting, and also the organization to different panel with different point of view, I think, has been key to ensure the success of this discussion. And you have been an excellent moderator, Claude, and you made a great job together with Guy and Jeremy beside you. So we heard about many efforts and ongoing initiatives in Europe, which are encouraging and steps in the right direction. And IRENA will be continuing to be engaged closely with the European Union and its member to work together in their efforts towards the acceleration of the energy transition. So thanks for this interesting discussion, and back to you, Claude.
Thank you so much, Francesco, for your summary, but also your nice words, especially also to my team, to Jeremy and Guy. But I have to give warm thanks to your team, who is providing the whole internet infrastructure to run it safely. And I think they were really excellent. And then also my thanks to European Investment Bank. We are quite proud in Luxembourg to have European Investment Bank located in Luxembourg, and they will be a very central actor. We need millions, hundreds of millions, billions, and therefore a good understanding of the banking community, of the need, and how also on how we can secure a long-term vision is extremely important. So thank you also for those participants who have endured 3.5 hours of I think, a very thrilling debate. For those who have missed parts, be assured that this event will be available online and on YouTube. So I think all the input from the panelists, the questions from the participants will stay alive, and I think I hope that it can inspire our European moving fast into where we need to go, where Greta and brothers and sisters push us, and I'm quite happy about that. We have a decade to win the race against, I think, extremely dangerous climate change. We can do it if we are able to bring all stakeholders together, and this morning was an attempt to do this.
Claude, if I'm, Claude,
Mr. Fayol join up, Claude.
Ah,
Mr. Fayol is there.
Ok. Ambroise, tu auras le mot final. Ambroise? Ambroise, you can speak. Is your microphone on?
No, he's muted.
So is the microphone of Ambroise unmuted?
No, muted.
Okay.
For the moment.
But I'm optimistic that EIB will find a technician. Hello, Luxembourg.
Maybe you just open the window and shout.
Yeah,
that's what I was suggesting. Just scream from the window.
Yeah, so I need to open the window, but next time I will take Ambroise to my table. That will be more safe. So should we give it another 30 seconds?
No, because it seems that he left now. He's not anymore in the list of panelists.
Okay, good. But then apologies to Ambroise if anything went wrong. We were quite happy to have EIB and IRENA co-hosting this event. Enjoy your lunch. Enjoy energy transition, a fast one. Thank you very much. Bye-bye.